Yo, hi. Hello. Today we do a little more problem solving. Think I mean, I can do like a code forces past contest or something like that. I remember reading about this thing on Reddit not so long ago. Like when doing problem solving, you need to submit a single source, so you cannot use dependencies and shit. But there are things like this which allow to bundle your code into one single Rust file. Mm. Proof I will need it though. Split into small grades as possible. Ah, okay. Let's see. Maybe I don't need that. Just wanted to check it out. There's also this thing, but it's not even in English. So not sure what that is about. Maybe we don't need that. Alright, here's what I want to do. We just do some problem solving. Is there a dark theme on Code Forces? No. Only as an extension, alright. Okay, I think we can do like one of the past contests. They usually are 2 hours for code forces, but there are some like this one over here. Is an online mirror of something. Homefest 15. I'm not sure what that is even. I'm not sure what it is, but I mean, it is a contest which has a lot of problems, and we can do it for 5 hours. If we do a virtual dissipation, this will give us exactly 5 hours to do the solving, and we can see how good we do. So that's the plan. That's what I want to do, I think. Okay. So we can start this in 4 minutes. Okay, let's get ready. So how do we do this? So we have like a main function, and we're supposed to get stuff from std in and get it from output to std out usually here. Right, so we're going to do something like cargo run. What do we have, by the way? Also, I think we can do like bin, and over here we can have multiple problems like A, right? And then we will be able to do cargo run bin A, right? And that's like our A problem, so that we can have all of them. All right. Then we can do a tests folder. Tests A and like 1txt something. 123 maybe. And we would be just running and taking the file into standard input, and I think this is how we run it. Should be good enough. Should be good enough. All right, 1.5 minutes. And then we start. So I'm not sure what this is, but should be like a regular ICPC contest. So we'll have some easy and some hard problems there. What do we have? We have installed Rust. I'm not sure. Hold on. Uncode forces. What is the current Rust version? I'm wondering. I probably just want to. Can I like get no notifications or something? I don't know. Guess I can just quit Discord. I mean, it's supposed to put me in the hello cage. Isn't it supposed to detect that I'm streaming? Discord is stupid. Alright, how are you doing, Cage? I'm doing no game development today again. One more time, we're doing some random shit, which is problem solving. My contest has just started, so you detected you are streaming. Good, you're a better detector than Discord is. Ambitious Kid is called the first problem in this contest. So Here we go. We start right now. Chineka, Pak Chinek's child, is an ambitious kid, so Pak Chinek gives her the following problem to test her ambition. Given an array of integers in one operation, we can choose one element and increase or decrease the element's value by 1. So looked at that page for 1 second to know I was too dumb. What is the minimum number of operations it can be done so that the product of all the things is 0? So in order for the product of things to be 0, it is enough for one of the things to be 0, right? Which means that in order to get the minimum operations, like we only need one item to become 0, which means that we want to find the minimum absolute value in the list. And so like this problem is ultra easy. Like, are you sure that you are to jump to this? Like this, it is super easy here, is it not? So let me see. Here's a test, right? Here's a test. I just need to figure out how to solve a problem here. First, let me see, submit. If I submit, I can do Rust, and it says Rust 1.72. Rust 1.72. Can I have a specific version of Rust for myself? Here. Version. Can I do a specific version of Rust here? Rust stable 1.72.1 maybe. Let's see. So not the latest, but 1.72.1 I think. Right? Let's see. This is missing. Okay. Oh wait, not 17. 70. Wait, is it 72, 71? 72 point, oh, 72.0. Okay. So that's exactly what I'm going to use for myself too here. Okay. While this is being loaded, we can start with actually writing code here, right? It should be really easy. Let's also reload so that rationalizer and everything is working. It should all be working here. Okay. So first of all, we need to read the standard input. Let's see, std io stdin log. This is how we read fast here, right? And then we want 2 read tokens there. Read line. Read line. Can we do this? Line. So in the first line, we are going to have the number of elements in the array, right? And then in the second line, do I do clear of the line? I'm not exactly sure. This is not the best part for Rust, like handling the input for these problems, I guess. Maybe we do something like that, so we can see this the statement of the problem and the code at the same time. Hello, Bad Cop. How are you doing? I'm doing Code Forces today, because why not? And I'm kind of like time restricted. I'm going to do a 5-hour contest, one of the past contests, and see how well I do. You invited Boats to make a game? Alright. You get Boats instead of me. Isn't Boats like a Unity developer, so you're going to make your game in Unity now instead of Godot? Okay, we read a list of integers. Integers are from 10 to -5 to 10 to 5. Okay, so I32 should be enough for that. Okay, so the solution to this problem is just get the minimum absolute value. Wait, split white space. Split ASCII white space probably is even better here. You're doing lawnmower game. I'm not sure what's lawnmower. Game. Such games don't exist yet? Okay, so I've read the input. Answer is the absolute value, and we find the minimum absolute value, and that should be enough. And then we just print it out, and this should be it. Let's see, cargo run. Your lawnmower will have multiple modes. Okay. Why don't I see anything? Oh, because I was writing in main. I should instead be writing like A. Okay, there you go. So yeah, for this, the answer is 2, and then we check other test cases just in case. This answer is 3, and this answer is going to be 0. Okay, this is easy. This is the first problem though. Okay, submit. Problem A. Gonna be Vampire Survivors, I think. Alright, good luck. You still want me to be on the team? I'm not sure if I want to do game dev, to be honest. That's why right now I'm doing this problem solving. Okay, the first one is accepted. So it took me 7 minutes. Alright, that's a little bit too slow, but I mean, I have not been doing this for a long time. Just gonna do something chill. Yeah. Okay, let's go to the next one. Okay. You can see, so like I'm doing a virtual participation, so I kind of like see what other people have solved so far. So we know that A is the easiest problem. Everyone has been solving that. And I can see how many people have solved other problems. So I know that this is probably the good next one. Let's read the description. On the trip to campus during the mid-semester exam period, Chineka thinks of two positive integers, x and y. Since two integers can be very big, both are represented using their prime factorizations. Oh shit. Chineke ponders about these two integers for too long throughout the trip, so her friend commands her, "G, stay, move fast in order to not be late for the exam." Because of that command, Chineke comes up with a problem: how many pairs of positive integers p and q, such as LCM, least common multiplier, right? And greatest common divisor, I think, are this thing. Oh shit, how many pairs of positive integers, such as that LCM is x and GCD is y? The answer can be very big. Output the answer modulo this thing. Oh shit, alright. That sounds a little more complicated than the other one. Smallest positive integer that is simultaneously divisible by p and q, and this is a common divisor. Okay. So since we are doing the since we are given the prime factorization, the GCD and LCM are kind of easy. The LCM is the maximum power for every prime, and the GCD is the minimum power of all the primes, basically. And we want for the LCM to be x. Oh, wait, hold on. We don't want to calculate the... Oh, wait, hold on. We want to find the number of integers being q such as that LCM is x. Okay. And GCD is y. So in order for LCM to be equal to x, it means that for every... So like the maximum of the prime powers of every prime over here should be equal to the power in x, and the minimum should be equal to y. So we know the maximum and minimum here. And if we know the maximum and minimum, if it's like only one prime, then wait, hold on. Isn't the so like if we know the maximum and minimum of two numbers, then there's only two variations, right? At most, or only one variation. Like if the maximum and minimum is the same, then it's going to be one variant, and if it's different values, then it's two, because either the first one is more or the second one is more. So yeah, we multiply by 2 every time the prime power is different. Okay, this is actually a very easy problem, and then we need to do the module. Okay. Let's go and solve this stuff. I think I want to have a function read line. Let's actually do like let read line be like this. Std in read line, and then we return the line, so that we have just a closure here like this. All right. Okay. First one is n. Okay, n is read line parse unwrap. So this is going to be the number in x per factorization, and then a the primes of the factorization, and then the exponents in the factorization. Okay. I see. Read line, split white space, map, select, right? So these are the primes, and then these are the exponents. All right. And then we do the same for M, C, and D. Okay. Sure. So now we also want the module here. Const mod is going to be equal to this. All right. What else? And now we actually like solve this thing. So we need to go and find the minimum and maximum of every prime, basically. Well, not the minimum and maximum, but like, I guess we need to find all the primes first. Let's convert, I guess. So like A is going to be, so I'm going to convert both x and y into the map from prime to the integer, because I feel like that's easier. Let's see, convert is no, let's instead do read actually. Read number. We're going to read the number, the primes, and then the exponents of the primes, and then we're going to do a into iterator, and then we zip that with b, and then we select into a hash map, I guess. Right? I feel like this is it. So we're going to do we're going to read the x, we're going to read the y. Okay, and now we finally solve the problem. So we do we need to like calculate all the primes. It's going to be x keys, and then chain with y keys, I guess. Then we collect that into hash set, maybe. So like this is all the primes that we have. Now we go for all the primes, and then we see the power of this prime in the x and the power in the y. So like in x it's going to be x get for the prime copied unwrap for 0, right? So if it's not there, then the power is 0, and then we do the same for the y. So then we do if x is not equal to the y, then those numbers are different, and we multiply the answer by 2. So answer, we multiply by 2, and we take the module. By default, my answer is 1. Also, over here, the answer is 0. Wait, hold on. How can the answer be 0? 2, 5, 1, 1, 2, 3, 1, 1. Oh, it's because the maximum... Okay, hold on. X is the LCM, right? So, yeah, the LCM is the maximum, the GCD is the minimum. So we say that if the X is less than Y, because the maximum cannot be less than the minimum of 2 numbers, right? Then it is literally impossible. So we do answer is 0 and we break. Okay, and then in the end we just do printing out the answer. This should be it. Let's take the tests. It's the first test. And this is the second test. This is the third test. Okay, and now we can try running that. So we're running the B test B1. For the first test, we failed to parse, because we need to, before parsing, we need to trim here. Okay. And I guess we also can just assert the equality of a length to be equal to n b. But I mean, we should trust the input here. Okay, so the answer is 8 for the first one. And then for the second test, the answer is 1. And for the third test, the answer should be 0. And we can probably now submit the problem. Should be good enough. All right. The problem has been accepted. That's cool. So the next hardest problem, it looks like, is problem number C. Or we can try looking at something else. But judging by the amount of submissions accepted, should be looking at C. Completely searching for inversions. Okay. We have an acyclic graph containing n vertices. Vertex I has Si edges directed away from that vertex. The jth edge is directed away from it, directed toward vertex Lig, and has an integer w. Okay, so we have an acyclic graph, and on every single edge we have a number written, which is either 0 or 1, because it's integer. Another information about the graph is that the graph is shaped in such a way that each vertex can be reached from vertex 1. Okay, so everything is reachable from the first vertex. We have an array Z that is initially empty, and then there's a DFS function which just populates the edges as we traverse them in the DFS. Okay, but the function does not keep track of which vertex has been visited, so that each vertex can be processed more than once. Okay, I see it. So like this this array can be quadratic size. I see. Oh, the function does not keep track. Okay, let's say that we do DFS once. After that, we get the array Z containing some elements 0 or 1. Define an inversion in array as a pair of indices such as that ZX more than ZY. Wait, what? How many different inversions in Z are there if we do DFS once? So we not only need to like, I mean, we probably don't need to calculate the Z itself because it's going to be too big. We are not actually going to run that program, but we want to calculate the number of inversions in the resulting array, which is and the array only contains 0 or 1. So an inversion in a 0 or 1, so ZX more than ZY means that we need to find the number of 1s and 0s. The number of, like... So basically for every 1, we want to add to the answer the number of 0s before that. Right? I guess so. Look at this, we have the animation here. Okay, so let's say that when doing the DFS, we are going into the thing that we have already been to, right? To the thing that we have already been to. Then it means that we're going to add something that we already know. But we want to calculate the number of inversions. Hold on. Okay. So let's see. I think we are going. So like our DFS is basically like returning this Z array, right? But instead of just calculating the array, we want to calculate the array, the number of inversions in that array, and also the number of 1s in that array. Because when we append something to the current array, like if we append to like an existing array another array, right? Then the number of inversions is going to be the sum of the inversions in the first half and the second half, but also we are going to add the number of 1s in the second half multiplied by the number of 0s in the first half. So that is it, basically. I feel like it should be a really easy problem. Let's start writing this. We need to read the graph. First, we need to read the number of vertices. And then we for every vertex, we find the number of edges from it. So for okay, so the graph is literally just the list of edges from every vertex, right? So graph is going to be 0 to n, and for every one of those, we are going to read the number of edges from that vertex, and then for every edge, we read the vertex that it gets to, right? So let's read the line, and we do line split white space, and then we get 2 integers on that line. So first we have the vertex to which we do. So it's going to be the first integer on the line, and then w is the next integer on the line. And there should be no more integers on that line. And we add the, okay, it looks like the vertex indices are from 1, so we are going to subtract 1 from this number. And then L and W, this is going to be a boolean because it says 0 or 1. Let's do that instead. So I'm going to parse into U8, but then I go into to see if it's not equal to 0. You convert into a boolean. And then L and W is the actual edge. So the graph is just a list of lists of vertex index and the thing. So we don't care about the indices here though. Okay, this should be good. Bars, consider specifying. Okay, yeah. Sure, let's do that. Okay, so we have successfully read the input here. And now we can just start solving. Okay. All right. So we are literally just going to write this similar to this function, but instead of pushing something, we're going to this is the acyclic graph. So if we have been, that means that we have been through it to its full. Yeah, so we're basically going to write something similar. Let's do DFS from the vertex this, right? I think we're going to need a struct for that so that it's a method, a recursive method. Let's see, solution. We're going to have the graph, which is this. So I'm going to do solution where graph is this thing. And then we're going to solve or something here. Let's see, we are going to implement on the solution. So we are going just because recursive closures are not very easy, that's why I'm doing this here. We're going to have the method dfs on self from vertex v, right? And yeah, and this is going to return this stuff. So like let's call this sub z. So like it's going to be like the subarray of the resulting like z stuff, right? Sub z. And like I said, I want to calculate the number of inversions, right? We also need to calculate the number of inversions modular this number, right? The number of inversions is going to be this, and then also the number of ones is what we want, right? Yeah. And do I want the number of zeros? We'll see what we need. So in order to do this, because we're going to get into multiple vertices multiple times, we are going to need to see if we have been in this vertex already. So like visited is going to be a hash map from a vertex to the already calculated sub z basically here, right? So if we have been there, if self-visited, okay, let's do this. If we don't have, if we have not been visited there, then we're going to calculate it. And in the end, we're just going to return the value here, right? This thing should be copy. All right, so if we have not calculated this, then we actually do this stuff. So we do for L and W in the graph of this vertex. So like these are the edges here. We are going to do dfs from the L, right? And the okay. I feel like let's just do zeros here. Let's just do zeros because why not? Okay. So we're going to start with an empty array basically, right? Which means that number of inversions is going to be equal to 0, number of zeros is going to be 0, and number of ones is going to be 0, right? So over here, we first push back, so we recalculate the number of inversions, zeros and ones. So if W, which means that it is 1, then number of ones is going to be increased. Otherwise, the number of zeros is going to be increased. And if it's a 1, then the number of inversions is going to be increased by the current number of zeros. So that's basically it. And we need to like calculate this by the module. So we're going to do this. Okay. Can I borrow self as mutable because it's also borrowed as a mutable? Okay, that is true. Oh shit. Okay, fine. We're going to do a reference here. Ah, I cannot do that. Can I? Maybe it's going to be easier if I... Yeah, and that's why like Rust is a little worse for competitive programming than C++, the borrow checker. Boom, 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 boom. I think we're going to just use the ref cell here because I don't know. Ref cell. So I'm going to do borrow contains key, and over here we do that. And over here, after we have calculated it, I'm just going to do self-visited insert. We are going to borrow mute here, and then we're going to insert for this vertex the subset that we have just calculated. But we need to calculate it here. So like the DFS is going to return this thing, right? And we basically need to append the thing that we have has returned here to the current sub z, right? So the part that we're going to append is this. So we are going to add the number of zeros. We're going to add the number of ones and the number of inversions is going to be increased, like I said, by the number of ones in the right part multiplied by the number of zeros in the current part. We're going to add that, and we're going to take it by the module. Can we multiply it here and not be overflown? I'm not sure. I feel like we need to do it like this here. And instead of U32, we're going to do everything in U64. Let's make it a little readable. I'm just going to add, and we're just going to take everything by the mod because that's all we need really. Sub z inversions, ones and zeros, everything we just take by the mod. Like this. Should be good enough. Okay, so now that we have solved this, we can call the DFS from the vertex 0 which is the first one, and then the number of inversions is our answer. Right? So we're just going to print out the answer. All right, there is only one example here, but it should be good enough for us to test it. So we're going to run the C on the one and only test that we have, and the number is 4. Okay, it looks like it's working. Okay, let's just submit it. I think it should be good. I think I was pretty careful when implementing that. Let's see. A wrong answer on test 3. Oh shit. Okay, well now we are going to have to think about it. Now we're going to have to think about it. I'm not the only one who has failed at this one. So maybe it's good. Maybe it's all good here. But what is actually wrong? There is no way I can do the overflowing here, right? Because this is like the most like dangerous part, I feel like. It's because we are going to multiply, but we are going to multiply the things that are less than mod, and this squared should still fit in a U64. So we should be good enough with that. So maybe that is not the problem. Let's see. So first we increase the number of inversions, and then the number of zeros and ones are just going to be increased. Yeah. No, I don't really see the problem here. Because the number of inversions, when we append an array, it's going to be increased by the number of ones in this array. Oh, wait. I see the problem. We need to add the number of inversions inside that other part. Okay. Yeah. That's the problem. I found it. Oh, wait, hold on. But now I have the 5. How do I have the 5 now? For this example. How do I have the 5 now for this example? Interesting. Oh, wait, hold on. Am I calculating this wrong? It's the number of zeros that are to the right of ones, right? An inversion is a pair of indices where the index to the left is bigger than the value that's to the left is bigger. So like 1 is on the left. Okay. So when we're adding 0, basically, then we add to the number of inversions the number of ones that were before that. Okay. I'm actually stupid. So we are going to add the number of zeros to the right multiplied by the number of ones on the left. Okay, now it's 4. Okay. I think we can submit it now. Now I feel like I have finally, yeah, that's like my mistake though. That we had there. Okay, now it's accepted, all right. Okay, what's the next problem that we are supposed to solve here? It looks like by the number of people who have solved the problem H, this should be the next one, the happy sets. Define a set A as a child of a set B. If and only if for each element of value x that is in A, there exists an element of value x plus 1 that is in B. Wait, what? Set A is a child of set B. For every element of x that is in A, it is x plus 1. So like B is basically A plus 1. So every single element is increased by 1. All right. Oh, hold on. There exists an element of value x plus 1. So it's like B is x plus 1 and maybe some more stuff. Given integers n and k, in order to make them happy, you must find the number of different arrays containing n sets. The number of different arrays containing n sets. This is so abstract, such that each set can only contain 0 or more different integers. Each set can only contain 0 or more different integers from 1 to k, and there exists a way to rearrange the order of the arrays of sets such as that they are the child chain For this problem, does print have higher precedence than modulo? What does that mean? How? What? Print the answer modulo? Yeah, I mean, yeah. The answer modulo should be printed. In the first example, there are 11 different arrays of sets possible, which are this, and then 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 this. Hold on, I don't understand the problem here yet. This is so abstract. Should the answer be print result module? Yeah. You can try that. Hold on, I'm doing this like contest, and I'm like a little bit on the time restrictions. We're going to do this for 4 more hours. See how well we do compared to other people. What is the current standing? I am number 204. I'm not that good, it seems. But this is mostly like done by teams, and I'm solo. This is one of the past contests. Who's Chineka? I don't know, like I don't know. They have her in every single problem in this contest, basically. The number of sets in the array and the maximum limit for the values in the set, alright. Okay. Each set can only contain 0 or more different integers from 1 to k. Do you have 2 hours of runtime allocated to you, or is it understanding and coding fixing as many problems as possible? No, the runtime is 1 second, not 2 hours. For a single test case here. So what I'm trying to understand right now is if we have the ordered sets like this, how is 2 a child of 0? It's not a 2 a child of 0, but a 0, like an empty set, is a child of 2. It's just you want to calculate the number of arrays where you can reorder so that like they are being child of the next one in order. So for that reason, like empty array and 2, and then 2 and empty array, those are like basically the same things. So like what I want to understand right now is if we calculate the number of ordered sets, do I just then multiply it by the factorial? Do I then just multiply it by the factorial? I guess the only thing that is not really like a factorial is when we have all empty sets. So like, because this is the only case where they are all the same. Wait, hold on. No. We can have multiple sets in the beginning of the sorted array, right? And the order of those does not matter. But the order of non-empty is always going to be like the same. So I feel like we're going to calculate the number of non-empty sets first and then like modify that answer somehow. Because if they are non-empty, then by calculating the number of ordered, we can just multiply it by the factorial, I feel like. And then we just insert the empty arrays in whatever positions, right? So we like multiply by C. Is this a prime number? I hope this is a prime number. Probably. Usually in these kind of problems, they give you the prime module. But I don't know. We can check, I guess. All right. And the reason I'm asking is because like we want to find the number to insert a certain number of empty sets into the like existing array of non-empty sets, right? Which means that I'm going to calculate the binomial coefficient, but the numbers are pretty high, so I cannot like just calculate them. I will need to use the factorial formula, and in order to like divide by the factorial, we're going to like calculate the inverse in this module. I don't remember how to do that though, actually. You know, I actually don't remember how to do that. Hmm. Okay, I will think about that. Let's say that we know how to do it. So we want to calculate the number of non-empty sets first, I feel like. And the number of ordered arrays of non-empty sets, basically, for every n and k. So in that case, we are going so I feel like the numbers in the first set. So like, because if there exists a number in the first set, then it should be from 1 to k, right? But it actually cannot be k, because for every subsequent set, we are going to have an element there from the previous set increased by 1, right? So for that reason, all the elements in the first set should be from 1 to k minus n. Plus 1, right? So these are all the options for the first set. And then after we go into every other set, we can also potentially add new numbers there, new elements that we do not have yet. Right? Okay. So the number of possible first sets is going to be 2 to the power of k minus n plus 1. And then what are the numbers that the amount of numbers that we can add to the second set? The amount of numbers that we can add to the second set is the numbers that we don't have yet, plus one new number always. So like 2 to the power of the remaining. This is a hard problem. Well, Tired Beaver, hello there. We're doing a Codeforces, one of the past contests, in case you're interested. We're doing this one. Is there a documentation from Rust to begin learning Rust? I suggest you learn from the Rust book. If you go to the rustlang.org, right? And then you click the button that is called Learn. There is this first link, which is called Read the Book. I suggest you do that. Okay. I have so far solved how many? The 3 first problems, and everyone basically who has been solving this at the for the same duration, basically everyone have solved these 3 problems. Some people have solved problem G, some people have solved problem H, and this is problem H. You know, while we are thinking about this, sometimes it's useful to just take a look at the other problems. Maybe we're going to know how to do this one easier. A train consists of n carriages that are numbered from 1 to n from left to right. Carriage I initially contains ai passengers. All carriages are connected by the carriage doors, namely for each I, carriage I and I plus 1 are connected by a two-way door. Each passenger can move between carriages, but train regulation regulates that for each I, a passenger that starts from carriage I cannot go through more than DI doors. Alright. That's such a weird thing, but sure. Define Z as the most number of passengers on the same carriage after moving. Are the instructions so that the array should be sortable, so that 2 is a child of 0 which fails, or 2 succeeds, that's very sortable. Yeah, that's exactly what it means. All right. Hold on though. I feel like this problem is actually easier, at least for me to understand, because like it's less abstract. Have trains, even though this is random. What do we have here? We have the initial number of passengers. So yeah, basically we want to move as much passengers as we want to one of the carriages, right? So we want and from a single carriage we can only move them up to a certain distance, basically. So for this one the answer is 5 because wait, what? Wait, hold on. The most number of passengers in one same carriage after moving. What is the minimum possible value of Z? The most number. Oh wait, so we want to rearrange the array so that the maximum. So like we want to even out all the passengers basically as much as we can, so that the maximum number of passengers in one place is as small as possible. So like, I feel like we can do. I feel like for that, it's going to be actually a binary search problem. So we're going to binary search on the answer and then see if it's possible or not. Maybe. It looks like you have actually understood the problem statement there pretty well, Hitus. Good job, good job. But that's not the solution. You just understood the problem so far. Okay. I think a binary search can be the solution here. So like in order to get 5 here, we need to move 2 people from this carriage to somewhere else. And we need to move 3 people from this to somewhere else. Русский, акцент хороший. Okay, yeah, we prefer to talk English here, even though I am Russian, because yeah, because more people understand English. I usually stream here game development. In case you were wondering, we are not doing the competitive programming here a lot. I'm just I just wanted to do it for some weird reason. Okay, yeah, I feel like the binary search and then like try to actually arrange the people is the solution here. So I feel like we're going to move from left to right and like do it somewhat greedily, I guess. So like we see that over here we have 7, right? So we are going to move like 2 people here somewhere to the right? So we like remember that, and we can move them at most 4 things, right? At most 4. Yeah, we like competitive stuff. So like we do competitive game jamming usually, or like when playing games, we like competitive aspect of it too. Although right now I'm competing against people who have done this already in the past. Right? It's not the contest that is currently happening. What is the input? What do you mean, what is the input? Here, we have the number of passengers in each carriage and the maximum distance that we can move them. I like this problem more than the other one. So I want to think about that one. I feel like I almost am at the solution. it also feels to me like over here, see, we have 8 people in this carriage and we can move them by 1, right? So we are going to move these 8 people to this one, but because we move them here, we need to move someone from here to somewhere else. So like we have like a chain of movement, it looks like. Can we just do it greedily? So like from over here, we do 2 to the right, right? So we are going to do 1 here, and then we are going to do 1 here. The question is, how do we move to the left if we are like going left to right? Like if I could only move people to the right, then the greedy approach after the binary search should work. Hello, Pigorli. Fellow competitive coder follower. uh... Maybe it's not the greedy solution then. Maybe it's more of a more of a, how do you like, okay, we'll have to do a Google Translate. How do we do this? Like pair matching? I'm not sure. How is this called in English? But I don't think so actually. The numbers are pretty big here. Maybe like the flow stuff, parity, like order evenness. No, you know, like these graph problems where you need to like select the most number of pairs in the graph. Those kind of things. In this case, the pair would be a passenger and a carriage, kind of. And then we have a limit on 1 carriage. It's like using the flow algorithms here, but no, actually no. It should be like something else here. Lloyd Warshall Thingo, maybe. Finding shortest path. No. That's just about the shortest path. I'm talking about like the flow graph algorithms. Maximum flow problem, this one. Do you know this one? So like you have a graph and then you like need to find the maximum flow stuff. But still, no. That's not the solution here. Even although it can be solved, but like the constraints, like there is an easier one, and the flow is not going to work with this number. Oh, okay. Hold on. I actually know exactly. It is the greedy solution here. It is the greedy solution. Let me try and explain here, maybe a little bit. So yeah, it's like, how do we move to the left? And the thing is, so like when we're doing this thing, we are going to figure out how many people do we need to like well, so like we have 7 here, right? And these 7 people can move up to 4 blocks. So we are going to have a segment like this, which goes 4 to the left and 4 to the right, and we are going to put 7 here, right? So this means that these 7 people can belong anywhere from this position to this position, right? And we're going to do a greedy thing here, I think. So yeah, that's how we like move them to the left, because we sort on the beginning of the segments instead of like on the middles, like I was like trying to think about before. So the question is, who do we put in the existing cell? If the existing cell can be covered by multiple segments, right? What segment is the best for us to take away people from? And I feel like the answer to that question is the one that is going to be the one that is the more limiting. So the one with the smallest right end, basically. Yeah. Yeah. So here's what we're going to do. Let's I feel like I have the solution. Let's do solving. Like I said, it's going to be binary search and then the greedy one. All right, so first we find the number. We do read line, parse unwrap. All right, and then we find the number of people. Read line, split, white space. Like this. We can assert that the length is equal to n. And then we do the same for the second array, the d, the distance. Okay. So we do a binary search, right? So first of all, what is the maximum value? The maximum value is the maximum in the array. So, and then the minimum value that we can potentially get is 0, right? Well, actually, I guess -1 is not approachable at all. Good morning, Rustman. Good morning. Good morning. So I think the left, like, is going to be the unapproach, the thing that we cannot do for sure, and the right is the one that we can do for sure. You know, the one that we can do for sure is the current maximum. So it's going to be a the maximum element in the A, right? And I guess it's going to be I64. All right. How is the project? Hold on, let's just have I64 here originally. How's the project? Which project? I'm currently doing the competitive programming contest. And my project that is like my game that I have been working on is currently on pause. We're waiting on something to happen to continue working on it. Okay, so we do while this is a non-empty segment, we calculate the middle point, and if we can like have the middle point sorted out, right, then like I said, the right one is the one that we can do for sure, and the left one is the one that we cannot do. So the answer is going to be in our right So we are going to just print out the right. And now we just need to figure out how to do that one. So we want to check if we can sort the people out so that the maximum number of people in one carriage is like, I don't know, let's just call it max. Right? This is going to return a boolean. So in order to do that, we're going to do the greedy thing. So we're going to construct a segment for everything like that, right? Let's see. I think we can sort them only once so that we don't have the... Wait, hold on. So the complexity of my solution here, I think, is going to be a log multiplied by n log. So n log square, which should be good enough. We have 3 seconds. But anyway, we can sort the original like segments where people can be placed only once. So segments going to be a list of the number of people. Why is it I64? I feel like I32 should be enough here. So the number of people and the maximum distance, which can be the U size, sure. And and hold on. So like the segment itself is 2 indices, right? Here's your solution, return 5. It is going to pass the first test case for sure. But there's probably more than just one test case in this problem, you know? Okay, so we're going to do A. We're going to zip that with B. And then we're going to enumerate, and we're going to map. So index, and then we have AD. So we're going to do okay, you know what? Let me just name those things instead of doing a tuple. I don't like tuples, you know? Let's just call it a segment struct, and we're going to have the start index, the end index, and the number of people, which is going to be an int like that. So we are going to have a segment here where the number of people is the number from A, and then the start is going to be I minus D. But we need this to not become less than 0, so I minus D, I, something like this, right? And the end is going to be I plus D. We don't care if we go after the end, but we don't want to go less than 0. Okay, so we're going to collect that. And change the closure to accept a tuple instead of individual. Yeah, sure. So like that's the tuple that we have here. All right, so now that we have these segments, we're going to need to sort them by key where, so we are going to start, we're going to need them sorted by their start originally. Okay, and now we're going to do this greedy stuff. It was n log squared, I thought, which is still good. Yeah, it should be still good. Like I said, we have 3 seconds, and the constraint. I feel like this solution can even like pass into 1 second when you have n log square complexity. Since we're doing Rust and not something like Python, it should be pretty fast. Okay, so we are going to move from left to right, and we're going to greedily put people into the carriages. At most, max people into one carriage, right? Right. Okay. You didn't know about sort by key? That's cool. Do you know Rust? Sort by key is pretty. Yeah, I feel like I use it all the time. I feel like I use it all the time when doing sorting. It's kind of like in Python. This looks like in Python, right? In Python, you do like sort, and inside you do like the key function. So like, yeah. Except for the input, I guess. Writing stuff in Rust is not that hard for competitive programming. I feel like maybe sometimes you have like problems with borrow checker a little bit, but I think that just takes a little bit of experience to do it fast. Okay, anyway, we're going to maintain the current so we're going left to right, and we're going to maintain the current segments that like still are undone, right? So we're going to have those like current segments as a B tree map, I feel like, because we are going to, like I said, first use people from the segment which adds which ends earlier. So we're going to have a B tree map, and the key is going to be the right end of the current segment, and the number of people that we have in that segment is going to be there. All right. So now we go for index in 0 to n, right? Because we need to put people in all the carriages here. And first of all, we're going to add the new segments that have started in this thing, right? So we do, I think we do the segments as an iterator of our segments that we had before. So we do while, wait, can I do a pickable? Pickable, yeah, I want a pickable iterator. Because we do while segments peak while the segment that is like the next in the sorted by the left end starts at least at the current index, at least at the current position, right? We are going to take that index and add it to the current segments. So we are going to take the entry for the segment end position, and we're going to add the segment number of people to that thing, right? Should be good enough. And by the way, the answer is that the current segments is empty in the end, I guess. All right, so we are adding the segments that are starting in the current position, and after we have all the segments added, we are going to start actually using them. So we're going to use the one with the smallest end position, which is just current segments first entry, right? I think we can do something like while let some and number of people is current segments pop first. So we're going to pop, and then we're going to like put it back if we like cannot fit them anymore into the current carriage. So like the space left in the current carriage is going to be equal the max, because like that's the maximum number that we can do for every single carriage, right? So we're going to do something like if number is less than, so we want to use all of the as much people here as we want. So if there is more people than space left, then we're going to need to put them back, right? Otherwise, we're going to just put them all there, and we're going to reduce the space that is left by this number, right? And in this case, we're going to put them back. So we're going to do current segments. Entry for the end plus equal number minus space left. So like this is the number of people remaining in that segment, basically, right? And the space left after that is equal to 0. And then we also break because we're not going to like do any more people. Value assigned is never read. I guess we don't need to set it to 0 then. We just do this. I feel like that's all the solution, actually. We just don't really sort things very often. Yeah. But when I do, I usually sort by key, I guess. I feel like that's all the solution if I did my binary search here properly. Casting to the same type is unnecessary, that's true. Okay. So now we just need to have a test case for the problem G. We have only one. Why do I call them txt? We can just do one. Use sort by key a lot in event of code. Yeah. I wish there was like a sorted set where you can sort by key without like making a struct with a custom ORed implementation. Okay, let's try running this. The problem G. Okay, so the answer is 5. Okay, I feel like this means that it's working, right? We're not really going to test it on more test cases. We're going to let Codeforce's website to test it for us. Problem G. Submit. Okay. Looks like it took me about 4... Wait, hold on. Wrong answer? No way. No way it's wrong answer. On test 4. Okay, well now we'll have to think about it. What do you think is wrong in my solution? Is this approach not correct? Is this approach not correct? One thing that I know is that we are adding those which have like 0 number, but I don't think it matters because we're going to like sort out all the segments. Even if we have a segment here with 0 people in it, it should not matter, I think. Maybe there is a bug in my binary search because this is a -1. Let's do a test where we have all zeros. The answer should be 0, right? The answer is 0. Okay, and if we do 1, then the answer is going to be 1. Okay. All right. By the way, instead of a binary tree map, we could use like a priority queue instead, because we only want like the first one. Here, anyway. But it doesn't matter. We are getting the segments that are starting at the current position. Oh, wait, hold on. Why do I say start is more than or equal? It should be like less than or equal. And in fact, it should be like exactly equal. Right? Because like if it means that I can put to the current cell people from the segment that like start somewhere else, which is obviously wrong. So like technically, because we are sorted by the start here, we're going to just take the ones that are at exactly the position I here. All right, I found the bug. Should be working, right? Advent of Code starts in how much? 1 day? It's exactly starting tomorrow, right? Okay, now we have a wrong answer on test 6. There's apparently one more bug somewhere. Shit. What's my bug here? In 23 hours. Yeah. Advent of Code, at least like the first problems are going to be super easy though, right? I never did Advent of Code like fully. Okay, any more bugs? Any more bugs? Is my first right bound correct? I feel like it is correct because the answer is at most the maximum number of people originally, right? My binary search looks good to you. I think my binary search is okay here. Is binary search like doing good when like the left bound is -1? I feel like it should be good. Should not break anything. Space left is max. We subtract the number of people that are going to like end as soon as possible. Yeah, first, okay. I don't know. I feel like this is the correct solution. What is wrong here? We can try what? What can we try? Let's take a look at the description. The numbers are from 0 to 10 to the 9, which should be enough for a 32-bit integer. n is from 0 to n minus 1. Oh, wait. I'm stupid. I forgot to like similar to this over here. I forgot. So like I'm adding new segments, right? And then I'm using all the segments that are like starting with the one that ends the sooner, right? But I never remove the segments. So like if basically over here, if this thing that is ending the sooner, right? If this thing ends has already ended, basically ended before the current position, then we just return false, basically, right? Because it means that these people cannot go anywhere. That's the missing part. I don't know how I missed that, because I basically before just used people from the segments that already ended before, and that's not allowed. So if that's about to happen, then we just need to return false here. Because if that happens, it means that there is no way to do it. All right. I don't know. I had the solution in my mind, and I just implemented and have two bugs. I mean, one bug and one missing part from my solution. Okay, there is apparently one more. Now we have a wrong answer on test 11. Shit. Okay, I actually know exactly what happened. So I feel like now we are actually overflowing. I literally just said that we are not overflowing because the int 32 should be enough. But look at this over here. I'm adding over here the segments. I'm adding all the segments, right? And what happens if all the numbers in the array are all 10 to the 9 power? In that case, I'm going and the segments are super big. They're all going to start at the position 0, right? And then I'm going to add basically into the first segment 10 to the 9 multiplied by 10 to the 5, which is no longer fitting into the int 32. So that means that that's a bug, another bug. So one thing that I can do is just use a priority queue, or I can, while adding them, just use an i64 instead. So I'm going to convert to i64 here, and I'm going to do an i64 here, and that should be it. Because like this adding could have overflown. I wish like it was very easy like in Rust to make a checked addition here. With say Perl, you just use numbers and they grow as you need them. Yeah, in Python you also just your integers become big int. But I don't like that this is happening automatically because it affects your speed, your execution speed. Okay, now it is a full solution. All right, it just took me 3 attempts. All right, let's see at the number of problems here. So yeah, the happy sets thing, I feel like we almost had the solution there. And I guess we have to solve it. All right. I just don't like, this is a little too much math. I never liked the mathematical and especially the combinatorics problems. It's just, I don't know. I'm just not into that, I guess. But sure, let's solve it anyway. So, like I was saying, we are going to do the to calculate the number of sorted arrays, and then we're going to insert the empty arrays into the positions. So the number of sorted arrays, like I was saying, the first array can either contain or not contain any number, which is from 1 to k minus n plus 1. Yeah. Then what happens with the next ones? Because we can extend the next one with new numbers, right? Because we can do 1 and then 1 2, right? So how do we do that? Maybe we do it somehow differently. Yeah, hold on. I feel like we do it somehow differently. 3 hours of fun still available? Yeah. I don't know. I mean, if you don't like doing that, then it's okay. But I feel like solving and doing competitive programming is actually fun. Some people think that participating in game jams is not fun because it's too much pressure. Maybe we need a different solution, you know? Let's do this. We are going, or we are not going, to have the number 1 in the resulting sets. Right? And so hold on. Here's what I want. You know, so like because in our ordered list of sets, we're going to like have 1 in the first set. Even if we have 1 here, then we're going to have in the next one 2, and in the next one we're going to have 3, right? Or we can have like 1 here and 2 here, or we can have 1 here, right? That's the thing. Or we can also have instead like start with 2 and we have 2 3 4 without the 1, or we can have 2 3, or we can have like 2, right? So for that reason, I feel like we are going to see so like if we are going to insert a new number, we are going to insert it in some position. Like 1 can be inserted basically in any position. Not in any position. In any position, if it does not end up with something that's higher than k, right? So like from something to the end. You have not been following this. Yeah, I'm not sure if I'm following my own thoughts right now. So yeah, if you want to read the problem statements, I'm solving this contest. I'm just trying to think out loud, but I'm not sure if I'm making sense to myself even yet. But yeah. So can it be something like 1, 2, 3, right? And can we add 2 over here again? We can, right? So we can have 3 sets, which first set is going to be 1, second set is going to be 2, and third set is going to be 2 and 3, because like we can insert the 2 again. The only problem that I am seeing is that we cannot have something like 3 and then have 2 2s here. So we can have we are going to have a collision. Two twos wouldn't be a set. Yeah, exactly. That's why, like, so like my thoughts were that I'm going to like select a position where I start inserting one, right? And this means that like all the sets in are going to like be like this. So like I'm basically inserting 2, 3, and 4 to the remaining sets, and then I'm going to choose the position where I'm inserting 2. For example, I can insert 2 here, right? And then I'm going to add 2, 3, 4, and 5 here. But the problem is that I cannot choose this position as a valid position to start 2 anymore. The last one is incorrect. It's not allowed. What is the last one? The last one you wrote. -3 and 1, 2. Yeah, I know that it's not allowed. I understand the problem statement. I'm trying to come up with a solution. But nothing 3, 2, and 1 is allowed. Yeah, but I'm also I'm only trying to like figure out the sorted ones first. And then we're going to multiply it by the factorial and insert some empty ones. So yeah, the problem that I see right now is how do I handle the collisions? How do I handle the not being able to like start inserting 2, 3, and 4 here again? Does it mean that just some of the places to start are going to be wrong? I guess so. But we still need like a formula, right? So the number of places to start inserting 1, we already know it's going to be like something like k minus n plus 1 something, right? Or wait, hold on. Or is it not? The smallest, so like for the smallest position is going to be n minus k. So the number of positions is going to be n minus k. Actually, we can just do 1 in any of the last k positions, literally, right? Any of the last k positions. So like it's going to be a minimum of k and n, the number of positions where we can start with the where we can start like the 1. Minimum of k and n. And then we can start with 2 at minimum of k minus 1 and n, right? But we cannot just multiply these numbers, right? We cannot just multiply these numbers because we need to handle the collision when we are going to start the 2 here. So do I just subtract 1 more from here? Do I just subtract 1 more from there? Because there is one position that is incorrect. But no. Because one of the things that we can do is like start 1 in the last set, but start doing 2 in the second to last set. So like we can do 2, 3. We can do a set of 2 and then set of 1 and 3. Right? Because 2 is a child of 1, 3. So in that case, when we are starting the 1 in the last position, it means that we are not blocking any of positions with the 2. So we can have this, or we can have just the last one is going to have the 2. Oh wait, hold on. I also don't want to like handle the empty cases here. I don't like this problem. Can we let's just take a look at something else. I know that a lot of people have solved this one, but like I said, I'm not really into that. Let's take a look at the D. There are n arrays. Each array has m positive integer elements, and the jth element of the ith array is aij. What should you set as your goal reached alert? What does that mean? For your Twitch channel, I just use the default one. You can set your to whatever you want. Initially, Chinaka's digital wallet contains a 0 money. Given an integer k, Chinaka will do m minus k plus 1 operations. What? What is m? Each array has m integers. We have 0 money originally. Every operation we does the following procedure. Choose any array. Choose index. Such that in that array, such that the index is at least p, and at most p plus k minus 1. I see. Add a value of this to the total money of the value. Change the value of that to 0. Determine the maximum total money that can be earned. What a national anthem. Did I change my mic? No. Did you know that one time Codeforces wrote hanged out on a problem? So what? What does it mean? First line contains n, m, and k, the number of arrays, the size of each array, and the constant that describes the operation constraints. It was a hung joke? I don't get it. Stupid maybe, I don't know. So I see, we have k, and we will do m minus k plus 1, which means that, okay, I see it. I see the thing. I see what's happening here. So we are basically moving a window of size k from 0 to m, right? And for every window like this, so we are going so like every window can be in one of the in one of the rows in our matrix, and we are selecting one number from that matrix, and we should not select the same number twice, and we like want the maximum number, okay, in as a sum. All right, I understand the statement here, but how do we solve this? How do we solve this? What are the constraints here? N is 10. Oh, hold on, N is 10. And K is also at most 10. K is at least 10, not most. No, K is at most 10 because it's less than or equal to the minimum of 10 and M. So even although M can be a big number, so like every single row here can be long, but K cannot be more than 10 because K is K basically is less than or equal to 10 is what is said here, but it's also less than or equal to M. So I expect a binary mask something here because of that constraint. 2 to the power of 10 is equal to 1000. So it's going to be a solution that is 10 to the 8th power, which should be good enough for 2 seconds if we do something like that. So we just go from left to right, and we know for the last 10 windows which ones we used and which one we didn't use. Okay, hold on. I actually know the solution here. So basically, we go left to right, and we so like when we are in this position, there is at most 10. At most 10 like of these windows that started earlier, right? At most 10. So this cell can be taken by one of those if we did windows, if we did not use that window yet. So it is a dynamic programming solution where we go over our matrix and we have a mask of the segments of the windows that we did not use yet. But I feel like that solution is still n multiplied by m multiplied by 2 to the power of k. So 10 by 10 to 5 by 2 to the power of 10, which is going to be 10 to the 9th degree, which is a little too much, unless some of those are actually not going to be reachable, some of those states, and my type complexity is actually less than nm2 to the k. Do you understand my solution that I want here? Maybe I need to like improve it by a little bit. Oh wait, hold on. But also like when I am at this specific cell, I want to like either take this cell or not take this cell. And in order to take this cell, I want to know, I want to like select one of the windows that I did not use yet, but that I'm going to use too. So it's actually also multiplied by 10. So 10 to the 10th degree right now, my solution, I think. So it's going to be nmk 2 to the k, the time complexity, which is a little too much. Hold on, but at the same time, if we had a window like this and a window like that, right? And for this window we chose this element, and for this window we chose that element. then it means that we could have instead chose this element from that window and this element from this window. So in fact, we are going in our answer to have sorted indices that we are choosing. You know what I mean? Yeah, so like the so we are going from left to right, from top to bottom like this, and we're going to select if we are like taking a cell or not into one of the windows, but we don't actually need the mask here. Because we are going to just use the first one if we can. So we don't need a mask. We just need to know how many windows we have available right now. Does that make sense? Why is this why does this feel easier than that set problem to me? Makes sense to you? Yeah, it does make sense to me. Maybe I can try and explain it better why I am going to be solving it. Okay, we have the NMK on the first line, and then we have n lines. So the matrix itself is going to be 0 to n, and then 0 to m. Actually, we just do a read line, split white space, parse, collect, and then we collect. This is the row, the list of we want to find the maximum total money. So we want every single element is 10 to the 6, but when we are going to add all of those together, we can get a big integer. I mean, U64 should be enough. So something like this is our matrix that we have now, and we are going let's see, what do I want here? I like doing the dynamic programming using the lazy recursive approach. So let's do that. And I'm going to have the max many is m multiplied by m minus k plus 1, which is about m squared. It's not m multiplied, but it's the maximum element, which is 10 to 6, multiplied by m minus k plus 1. So it can be 10 to 11 power. Okay, so I'm going to do the dynamic. I don't know, let's just call this f, whatever. Okay, so we are, let's say that, so we are going like up, down, left, right. So at a row this, at the column this, right? And we know that we have the windows available to us. Let's just have the starting window that is available to us. So like I don't know, let's just call this window usize. All right, let's just do this. So let me just write the recursive function here, and then we're going to add memoization on top of that, which is going to turn it into like dynamic programming stuff. And this is going to return ourselves the answer, right? So we are either going to take the item and the row column, or we are going to not take it. So if we are taking it, so like if we are taking it, then the answer is going to be the thing at this row, at this column, right? And then we're going to take it, and then we're going to go to the next row, next column, right? Let next row and next column be if row is plus 1 is equal to n, then it's going to be first row again and column plus 1. Otherwise, it's going to be row plus 1 and the same column. All right, so we are going to continue to the next row and the next column. You find the streamer a lot easier to understand than the typed language. Wait, what? The arrow to the U64 in a typed language doesn't scream, and this is going to give us the answer. I mean, this is going to give us the answer, like starting from the current position that we're at, basically. So like the partial answer, and the total answer is the answer when we start in the very beginning, basically, right? Okay, so we're going to move to the next row and next column, and because we have taken this element, our window is our like window that we can use is going to be increased by 1, right? And we can only do this if we can take this element, and we can only take this element if the window if the start of the window, if we have an available window. So like this is the window that I have here is the start index of the last window we can use. So like if the start index is more than the current column, then we cannot use it. So like only if this is less than or equal to the current column. So we do this, but then this, something like that, right? We don't have the access to A here, which means that we're going to have this as a inside our struct. And that's like the global data. So self a length which is equal to n, All right. So this is when we are taking it, and if not take, then we are going to just not take the current cell, and we are not going to use the current window, right? So we're just going to calculate the function for the next row and the next column, and the window is going to remain the same. Now we need to restrict only the length of our windows. So I'm going to say that window is like the last window that we can use cannot start earlier than column minus k, which is the size of our window, right? Is that correct? Is that correct? No, we need to do k minus 1 here. Because in case like k is equal... Hold on. In order to capture this column, the start of the window should be at most the current column minus the size of the window. Plus 1, right? Okay, I feel like this is it. All right, so now we know what is our answer if we take the current element, if we don't take the current element. So we do something like if take, we convert that into the iterator, and then we chain that with if we don't take, right? So those are our options, and we want out of all of our options to take the best answer, and the best answer is the maximum one. So we take the max and we unwrap that, and that's our actual like answer, right? So that's our actual answer. And now we need to add memoization on top of that, which is going to turn this into the dynamic programming thing. So we are going to have the memo here. Maybe let's do a ref cell, sure. And memoization, we just do a hash map. Hopefully hash map is like good enough in terms of like memory. Instead of in terms of performance, I don't like just doing arrays. So like the key is going to be like the row, column, and window, right? Just like this. And then the value is the actual answer. Okay, so let's see. Key is row, column, and window. And if self memo borrow contain, if we have not calculated this yet, then we are doing the actual calculation, and this is our answer that we're going to put into our memoization stuff. So we are going to borrow mute and then insert for the key this actual value, right? And then after we have calculated this, we can safely take it from here. Right? So this should be good enough. So we do solution AK and memo is ref cell fault, something like that. We do the solving when we started the row 0, column 0, and window is 0, and that is our actual answer that we are going to print out. Okay, if I did not do any bugs here, this should be the actual solution. Let's make a test. D. We have multiple tests here, which is good. Let's see, run the D. We have panicked. Of course, we have panicked because if column is equal to the length of the current row, which are all the same, then we are going to return 0 because like we cannot take any more stuff. Okay, the answer is 27. Looks like it's working. Okay, let's just test all the other tests here. The second test is going to be this. And the answer is 24, which is wrong. Okay. For this one also is also wrong. Okay, how can we do... Okay, we can try like restoring the answer and in like not only take the thing, or we can just try and see if I can spot a bug here. So for the second test, the answer should be 17. We have the maximum is 2. All right. How can I find the answer that is better? Is window plus 1 not the correct thing here? It is 24 because like I allow more stuff to be selected probably here. One, two. We're supposed to only select 2 numbers, right? Oh, wait, hold on. Yo, Adam, thanks for the raid. How's your stream? I'm not doing game development today. In case you did not see the stream title, we are doing some problem solving for the competitive programming. Hello, Arya. I'm doing Code Forces, one of the past contests, which I'm doing in virtual mode, and I have 2 hours and 40 minutes to like do the solution here left, because I'm doing like a virtual participation. I know what is happening. I know what is happening, and what is happening is that for the like the window. Did you solve the problem from yesterday, the tree problem? Yes, I did. I could. There was someone in chat who did it without the trip, but with 2 priority queues, basically 2 binary heaps instead, which I feel like is nicer. But my solution is like more generic. If you have the data structure, then it's easier with my solution, I think. But if you don't know how to write it, you could do it with 2 binary heaps instead. Okay, so we are solving this problem, the digital wallet, which is like the dynamic programming stuff, and I have one bug in here, which I know what it is, and I'm going to fix it right now. The problem is that I assume that we have more windows that is actually available here, because over here we have windows of 2, which is like a window like that and a window like that, but I am also considering a window that starts from 4, which I should not, which is why my answer is better than we have here, which means that we also return 0 if window plus k is more than the length here. We also return 0 then, right? Because that window does not exist. The last window that we can use is when it's exactly equal. And I feel like in that case, we're going to actually have the 17, which is the correct answer for the second test case. For the first one, it's still 27. And for the third one, it's going to be 19. So that is going to be the solution. The complexity of this is number of rows multiplied by the number of columns. So like 10 by 10 to 5 multiplied by the maximum window size. I do it before calculating the key actually, and so it's going to be 10 to the 7th. I think my complexity here, which should be good enough. All right, let's just submit this, and this should be working. This is D. So far, out of this contest, I have solved 1, 2, 3, 4 problems, and this is now my number 5. I see that a lot of people have solved the happy sets, but I hate this problem. But it looks like by the number of people, it should be easier than the one that I just did. Memory limit exceeded on test 45? No fucking way. Hold on, I'm using more memory than needed. All right. Is it because I'm using a hash map instead of doing a proper like just array? Okay. So what is the amount of memory that I use? It's exactly the same as my time complexity. I'm using the same amount of memory. Okay, you know what? This solution can be solved with the a lot less memory because I don't need to do that, but then I need it to be not a recursive thing. Then I need it to be not a recursive thing. So I need to rewrite it. Because 2 multiplied by 10 to the 7th U64 looks like a little too much memory, right? How much memory am I actually using? So it's going to be 2 multiplied by 10 to 5 multiplied by 10 and multiplied by 10 and multiplied by 8 bytes, right? So this is how many bytes I'm using. This is how many kilobytes, and this is how many megabytes. That's a little bit too much megabytes. Oh, wait, hold on. 10 to 5, not 15. Wait, hold on. I'm actually using only 152 megabytes. But that is only in case I only store the answer, because but I also store the key because I'm using a hash map, which means that I use actually 4 times more memory, which is why it's bad. But if I was to use an array instead, it would be good, it seems. You know what? I'm just going to rewrite this because I don't know. Okay. Or we can just do a vec here and do a different solution. For like instead of checking that it contains the key, I need to see if the value at the key is equal to, like, we can do like -1, I guess, and -1 is going to mean the what is this site? Do they validate your submission on their own hardware? Yes. It's like LeetCode, but more for competitive programming. It's called codeforces.com. It is more competitive than LeetCode. So like, yeah. Because it's more about competitive programming than just doing the interview questions. All right. So I just changed the storage here because I feel like I should have enough memory here. So I'm going to just use the value of -1. Actually, I can use the value of 0 because the answer is never 0, right? The answer is never actually 0. So if this is 0, it means that we have not calculated yet, and we are going to calculate. And in order to calculate, we, instead of inserting, we set the value at the key to be that. Okay, so the key is going to be, instead of just a tuple and doing a hash map, we're going to calculate the index into the thing, which is going to be row multiplied by... Ah, shit, I don't like that though, fuck. I need to like, I don't know. Okay, fine. I mean, I still can do it. Max, max column. Max window. Okay. Okay, so in order to like get the correct index here, we are going to multiply. Let's do... I mean, or instead of a vec, we can do something like actually array. Actual array. So like the index on the outside is going to be the maximum n, which is going to be like 10, right? And then inside of that, we're going to have the m, which is 10,000, 100,000, right? And then inside of that, we're going to have the maximum 10 for our window. Right? 11 maybe. And then over here we store the actual... I don't know, this is ugly. I like with my hash map more, but it uses a little too much memory. So instead of doing the key, we're going to use the first index is going to be the row, the second index is going to be the column, and this third index is going to be window minus max window, because this difference is at most 11, at most 10, which is why we do this. So we don't have the key, we just do this stuff. This is our indexing. And then default is not satisfied for an array of this much size. Hold on. I cannot do an array like that, right? It seems like... Ah, why is this so ugly? All right. Okay, you know what? I'm actually going to rewrite this. Instead of doing memorization, we are going to do some other stuff. So we are going to like basically go from right to left and not do a recursive approach with memorization. Just save the previous like the next column. So like when we are at the end, the answer is always going to be 0, and we are going to need for we're going to need for our dynamic programming the next. Just do hash map something new, and we are going to first say, wait, hold on, we just need for the previous position, right? We just need the answer for the previous position for every single like window size, right? So basically we like need to iterate over all the positions in the reverse order. And all the memory is going to be at most like the for the windows that we have. Like all K extra memory is technically enough for this problem. That's annoying though. I wish they just had me more memory so that I just had this problem accepted already. Pam, pam. Okay, so we do something like for a row in 0 to n, or column in 0 to m, and we are going to do this in reverse order, right? For the rows, it doesn't matter if we go up, down, or down, up. It's just we need to do columns from right to left. Do you need U64s, or are the results small enough to fit in U32? No, we do need U64 because the answer can be more than 10 to the power of 11. I mean, at most, it's 10 to the power of 11. That's why we need that. But my hash map approach previously was bad because like the key that I was using was also like 3 U size. U size is basically a 64-bit, so like I used 4 times more memory than I technically like used for just the values. Okay, we just do iterative approach instead of memorization. It's like I like my dynamic programming usually with memorization and recursive formulas, which is why I did this first. So instead we're going to iterate over all the possible like things that we need to do. So window in column maximum column minus of k minus 1 column, because that's the maximum column, maximum window start, I guess. We just do the same stuff. Or window in so that's It's just annoying. I need to like understand how to do it properly here. Like the lazy approach is so easy. Okay, so like all the possible windows are starting from this position and ending at the column +1, including this, right? So that's all the windows, and over here we are doing actual this stuff, right? So we calculate that, but instead of calling this stuff recursive, we just take from the previous like iteration. We get for the new window, which would be window +1, unwrap or 0 if it's not there. I mean, it's actually, you know what? It should always be there. You know, let's make sure that it's always there. Let's make sure that it's always there. Which means that originally we are going to do dp insert for the m so like how many windows we can even have here potentially. I guess we can have at most like k, right? So like from 0 to k. Let's just do this. So we can take only if we have at least one window. So if windows is more than 0, right? Then we can take. And if we take, then we reduce the number of windows by 1. And we can potentially do one more window plus new window. Let's calculate. So new window, are we going to have the new window or not? It's going to be there only if column plus k is less than m, I feel like. Then it's 1, otherwise it's 0. Okay, so in this case, if we don't take, then the number of windows is going to be increased by 1, but it cannot be more. It cannot be more than k windows. I need to take the minimum there. Okay, so we do the same thing, and this is the current answer. So we are going to insert this into the current DP. So current DP, we insert for this number of windows, this current value that we have calculated. Current DP is a new hash map. And then we replace DP with current DP basically after every iteration. Type annotations needed, max window, we don't need max window. Is that the solution? So then the answer is going to be DP at the number of windows that we have originally is 1. $42. Now we have the wrong answer. Amazing. 37. Okay, well, I hate this now. Now I do the same solution and it doesn't work anymore. How do I get the bigger answer than I had? So the number of windows is the number of the windows that we have starting well, yeah, covering the current position, and it can be at most k windows, right? Right. So what is wrong here? For row in 0 to n, the loop variable row is only used to index a. Well, I mean, yes. It's not a bug. Wait, hold on. We need we need this to be the outer loop, and the row should be the inner loop. Yeah, that's pretty important. No, that we have even worse answer now. Hold on. What am I doing wrong here? What am I doing wrong here? This loop should be the outer loop because we solve from right to left. Yes, that's why we do the reversed iteration from 0 to m. And instead of that, we do for rows. Hate this. If we take the current cell and also we get the calculated answer from like the previous cell or like the next cell where the number of windows is less by 1, but we also maybe have a new window. Oh, hold on. We also might have a new window here, right? +1 is not always true. New window is what we need to add. We just don't subtract 1 in that case. Okay, it is still wrong. 44. Ah, this is the first test. Let's do a simpler test maybe. Let's do a simpler test. Test number 4. We are going to have 1 by 1, and the window is 1, and the thing is 1. The answer should be 1, right? And the answer is 1. Okay. Let's do 2 rows. We have 1 in both of them. The answer should still be 1. And the answer is still 1. If we have instead 1, 1, so like 1 row and 2 columns, then the answer should be 2. That is 2. Okay. So now if we do 2, 2, and 1, 1, 1, 1, the answer should still be 2, but it is 3. And why is that? Oh, wait, hold on. I know why is that. Because the new column, new window, we're only supposed to get it if we are like moving to the next column, right? So with this, and we also, since we're like doing this iteration like that, we're only doing that if row is 0. Okay, yeah, maybe this is it. 27, 17, and 19. Okay, finally. All right. I hate this so much. Like the first solution was so much better in terms of like understanding the code. I feel like I don't like dynamic programming doing like without the lazy recursive stuff. So much more ugly. Okay, but this should work. D. Now we have wrong answer on test 30. Oh my god. Okay. I made my solution worse. New window. Yes. The maximum number of windows that we can have is k. That is true. There are only 2 options. We either take or we don't take. We can take if we have a window. Yes. And we're going to get a new window if we're going to the new column, which is when we are at the first row. And if on the next column, basically column plus 1, which is the next column, and plus k should be less than or equal to m, which is like exactly the same stuff that I had written before. Number of windows is from 0 to k. Is it because the number of windows cannot be equal to k in the last column, for example? Can I break something because of that? Because in the last column, the number of windows is always 1 at most. Should I delete my windows sometime? Sometimes. Yeah, I feel like yeah. I think that's the problem because like we should not have more than one window. So like we need to have the maximum windows. Maximum windows is maximum amount of windows is m minus column, right? So windows is the minimum of that and max windows. Because otherwise I can take multiple values from the last row, which I actually cannot. And in that case, from the last column, we will only take one. Let's just do this. Just submit. I believe in this. I'm not even going to test it. It's just going to work, right? 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 Right. Okay. Finally. Finally. Okay. I feel like I had this solution from the very beginning, but it took me too much time. All right. Let's see. Okay. So it looks like everyone has solved this problem H, but I have not. But I hate this problem. I have been thinking about it. Maybe I need to think about it again, like in a different way. So here's what we have. We need to calculate the number of different arrays of n sets which satisfy these conditions. So like I don't see the solution here yet. I just don't like this problem in general. I still want to think about the other one. Let me at least see, and if the next problem I'm not going to come up with immediately, then I'm going back to this one. But let's see, what is the next one that people have been solving? The problem L, it looks like, is the next on the difficulty. After working at a factory, the guy wants to play a game with his good friend. There are n boxes numbered from 1 to n. The ith box contains eyeballs. We'll play a game using these boxes. There will be n turns numbered from 1 to n. On each turn, we choose a box and take all balls from that box. And then the other player does the same thing for one box they choose. It's possible that the two boxes chosen are the same, in which case the second person is not going to take any balls, right? Given an integer m before the game begins, the second guy chooses an integer k. It is known that on the turn j, Akchanek will choose the j box. While this Oh wait, hold on. So the strategy that they're playing with is already known. Okay, they're using a specific box. So like the first player is just choosing the boxes in order, and the second one is using that formula to determine the box. Help. Choose the correct value of K so that he will get as many balls as possible. I see. And then if there's multiple possible values, then the minimum K. Okay. And K is going to be from 1 to M. 2000. So what we need in this problem is to figure out how many balls we're going to have if the K that we're going to choose is going to be a specific one, right? And it looks like it's going to be just like a formula. Maybe it's not a formula, because we're not going to do the iteration from 1 to n. Oh, wait, hold on. Integer m. Oh, no. There will be n turns. So, like, on the first turn, we... Okay, so on the turn number j, all the boxes from the first to the j are going to all be taken, basically. So we only have balls in the boxes starting from j plus 1, right? So we're doing this random iteration, and we are only taking it if this is more than j, basically. Mod n. So we take big steps. Okay, I feel like I do see the solution here. We can kind of like model the game, but we are basically what we are doing is we are taking steps. So the first player is just taking the balls from the first one, then from the second one, then from the third one, etc. Right? But what we are doing is we are taking it from like K. So like let's say that's K is 3 here, we're going to like K, and then we're going to 2 more. And if we are overflowing, then we're basically going from the beginning again. And then we're doing this, you know? So because we are basically always are moving at a speed of K, and the other player is moving at a speed of 1, it means that we are faster. So we only need to know how many are we going to, how many like boxes are we going, how many steps are we going to do until we overflow, and then we need to figure out where we are going to go, right? And then we need to figure out where we are going to go. Okay. Yeah. And then we need to figure out how many more steps we need to do until we like are in front of the first player. And the other thing that we need to keep in mind is that we should not move into the place that where we have been ourselves before. And the number of places that we can be in before is at most k. So this is going to be a quadratic time solution. Yeah, okay. This is easy. Why has everyone solved that other problem that I don't know how to solve, and these ones are easier? This is problem L. This is problem L. Let's do the solving of this. Okay, something like this. We read the input, and then after we read the input, we need to so basically we're going to pick the value k, right? So for k in k that we're allowed to choose is from 1 to m, so from 1 to m. And now we need to figure out what is going to be our number of balls, right? So let's like have a function balls of k and m, right? And if balls is more than the max balls, then max balls and answer is k. Max balls is 0 and answer is 1. Okay, so now we just need to figure out this formula, right? Now we just need to figure out this formula. So the number of balls that we're going to collect if we have this k and if we have this m is going to be u. Let's just do u size, whatever. No. Well, actually, like technically, let's just do u64 instead. Everywhere, because that's going to be the answer. I feel like should fit into 64-bit integer. Okay, so we are going to do what? So in order to, why am I so competitive? How are you doing, Davey? Isn't this the last day of the GitHub game off? Is your game done? Let me see. HIO. Do I have the notification that Davey has released a game? I do have one notification, but it's not that Davey released a game. Why don't I not have the notification that you have released a game? Are you working on it or like right now? This is the last day of November, right? You did not forget that you need to release a game, right? So that you can finally go back to working on Linksider tomorrow, right? Let's not talk about that. Wait, if you're not releasing a game, why are you not working on Linksider then, huh? Or are we not supposed to talk about that too? Okay, anyway, I'm solving a problem here about balls. All right. Okay, so one of the things that's important here is to make sure that we don't go into the same place. So let's see, visited. It's going to be, let's do a hash set. And if, first it's going to be the empty one. So our position originally is going to be 0. We're going to start at, wait, actually it's not going to be 0. Is it going to be 0? No, it's going to be k module n, I feel like. Right? That's our first position. So then we do while. And then the visited are only going to be differ by the module of our position by the k. So like position module k, while this has not been visited, while not visited contains this value, right? We can actually like go ahead and like overflow and everything. So first we need to figure out how much do we need to move until we are in front, right? So here's the formula. Position plus k times like t should be more. Oh, also we need to know how many turns, right? So like how many turns have been done. I don't know. Let's do turn. Originally it's turn 0, right? So if it's turn 0, then the other dude's position, it's basically the position of the other dude, right? So position plus k times t should be more than turn plus t. So, and t can be anything from like more than or equal to 0, basically, right? I feel like that's the formula. So this means that t multiplied by k minus 1, it should be more than turn minus position, right? Which means that t is more than turn minus position divided by k minus 1, right? Is that correct? Is that correct? Formula. So now we need to do something like we need to divide while routing down. Divide while rounding down. Turn minus position divided by k minus 1. The only thing is k might be 0, right? In that case, it's never going to happen, seems, because we're moving at the same speed. So like k, if k is 1, well, I mean, technically if k is 1, then the answer is actually 0, because we are the second one, right? So if k is 1, then we just return 0. So yeah. So we need to have this as a separate function because this can be negative. And in that case, we don't just round down. And also when we are doing the subtraction here, we need to do this as not unsized, I guess. So we do I64, B, I64. So we divide down and then we add 1 to become more than that, right? And that is our t. Right? And then we say that t is like this should not be negative, right? T max of this and 0, and then we convert this back to the U64. So that's the number of turns that we need to do before we are in front. Let me implement the div down though. So basically, if a is less than 0, then we need to return negative div while rounding up of negative a and b, right? Otherwise, we just return a divided by b, and that's how we round up. And in order to divide up, not divide up, divide and while rounding up is what we do here. So over here we have a more than 0 and b more than 0. So we do just a plus b minus 1 divided by b. So that's how you divide while rounding up. Actually b more than 0, it's not even equal to 0. Okay, so there we go. Now we have figured out how many turns we need to do until we are in front of the first player, right? So we do turn plus equal t, right? And now, since we are in front, we need to figure out how many turns we do until we are in front. So like it's going to be similar. Position plus, and also we do position plus equal k times t, right? Yeah. So the next thing that we're going to do, is figure out position plus k times t when we are going out of the playable area. So more than or equal than n, right? In order to do this, we say that t is more than or equal than n minus position, right? Divided by k, right? And also let's do this actually. You know, if a is less than 0 here, return negative div down negative ab. Okay, they are like recursive like that, because over here we will need to divide while rounding up. So we are going to do here, this is our overflow. I mean, so this is the t when we are overflowing, right? And this is going to be divide while rounding up and minus position a, right? All right. And obviously, so if this is negative, if t is negative, it means that we are like already overflown. Actually, hold on. We do not do this. I just realized. Okay, so hold on. We either overflow or we get in front of the other of the first player, right? One of the two things happen first. So this is t for racing the first player, right? When we are in front. So let's not move yet. Let's not move yet. We instead just figure out T for overflowing is this. So like now what is happening first, right? So if so what is happening first? If we are overflowing before we are overflowing before we get in front of the first player, then we just go ahead and overflow, right? I mean, we're going to overflow anyway, but I guess if we overflow after we raise, then we get at least some balls, right? Then we get at least some balls. And what balls do we have? Do we get? We get balls from so like it's going to be the arithmetic progression. The first one is going to be current position plus k times t raised, because that's the first position that we're going in, right? And then the last one is going to be position plus k multiplied by overflow minus 1, right? And then so to the answer we need to add the average multiplied by the number, because that's the formula for the arithmetic regression, which is going to be t overflow minus t raised, literally, right? And then we return the answer. Hold on, I feel like I have missed something. Feel like I have missed something. There's no way we're overflowing. So this, I think I can assert that overflow happens like it's more than 0 actually, because we are always inside. We're always less than n. Okay, then we can do n-sized stuff here. All right. So after that, we basically go to overflow, right? So we do position plus equal k multiplied by t overflow, and then we take module by n. That's our changed position, right? And the turn is going to be plus equal t overflow. I think that's it. So we are going to do at most k steps here, which means that it is a quadratic solution. All right, let's do testing here. Cargo run the L. Unused variable n. Wait, what? Why is it unused? Yeah, it should be n here. Okay, found a bug. Okay, 3, 1, the answer is 1. And then 5, 4, the answer is 3. Okay, it looks like it's working for these things. For this test. These tests are a little too simple though. But at the same time, do I believe that this is going to work? Or we just allow the website to test the thing for us? It's L, the balls. Let's go. I think this should. If it doesn't work, then I try to find the bug. Wrong answer on test 7. Oh shit, okay. Okay. Alright. Now we need to actually figure out where the bug is. Okay, is this correct? So when we are, so like, why is this the condition for my while here? It's because if our position module k is the same, it means that we are basically going back to the position that we already have been to. Right? Wait, hold on. Maybe this is incorrect? Hold on. Is it k module n the first position, or is it actually k minus 1 module n? Because they are using 1 based indices here and I'm using 0 based indices. So I feel like my first step is incorrect. Is that true? I think that might be the thing that I have missed. The first step is like the k in 1 index, and it's k minus 1 in 0 index. So yeah, I feel like that's the bug here. Let's just submit it. I find a bug, I fix the bug, I submit. Groovy is competitive only when it comes to getting balls in order. Okay, looks like we passed that test, alright. That actually was the bug. Accepted, alright. It seems like that problem about sets, this one, that everyone has been solving is like, I don't know. Something is wrong about this one. I don't... How many more hours? We have 1.5 hour more. This stuff. I'm currently going in such a way that I would be on the position... Wait, hold on. Where is me? Where is me? Okay, I am positioned at 170, but people who were solving this contest, they were solving it in teams of 3 people, and I am just one of me, alright? I feel like 170 is pretty good here. Alright. I wonder why can I not come up with the solution for this one, though. It seems like this should be an easy problem. Let's go back to this one. What do you mean? What do you mean by what? This is I'm solving basically a contest that has happened before, so I'm competing against other people who were like, we are a lot bigger team. Oh, that's what you mean. All right. Yeah, but chat is not really helping, right? Chat is not really helping. Good morning, Nightlight. Hello, hello. In competing teams, they're all also members who are distracting. Not in good teams. In good teams, they are helping each other, not distracting each other. But in 170 level teams, the thing is, you know how many teams there are in total there? Like, I am number 170 out of 5,000. So I feel like that's not that bad, you know? Especially since chat is distracting me. Alright. Happy sets. The happy sets make me sad, you know? I don't like this problem. How do I solve this? Alright, let me try and think about this a little more. Have you projected how far higher is reachable? I can be pretty high there. Like, even especially with practice, like I have not been doing competitive stuff for a long time, right? So I feel like I can be like pretty high up there. Maybe like in the top 50 should be like kind of easy doable. You know? You know what? Also, I have just realized, hold on, the way I've been thinking about this, we can have a set which has 1, and the second set can have, because of that, 2, and also can have 3, right? Oh, wait, hold on. No. Oh, no. Here's an example. I want, like, the first set is 2, and this third one is 3, but also additional 1, right? Because this is a child of that. Oh, I guess, no. The other way doesn't make. I was just saying that like in the other order, like because 2 is more than 1, then like 1, 3, and 2 is also correct in terms of like it is also correct, but like I'm trying to like do the without the reordering them first. Did you try solve multiple simple problems to get points faster? This is currently the simplest problem that I have not solved because it has been solved by 300 people. Like 400 people, you know? And the problem that I just solved was solved by less than 100. So the problem that I just solved is technically harder. But let's still like continue because I have no idea right now about that one. Let's continue with the other one. Okay, this game is a rock tower game. There is a big rock that is used as a base. There are also n small identical rocks. There's big rock that is used as a base and also n small identical rocks. We can use them to build a rock tower with height of n above the base rock. Initially, there are no small rocks that are located above the base rock. In other words, the height of the tower above the base rock is initially 0. In one move, we can place one small rock onto the top of the tower, which makes the height of the tower above the base rock increase by 1. Each time we place one small rock, the following will happen after the small rock is placed. Let's say x is the height of the tower above the base rock right after the small rock is placed. There is a probability percent that the topmost rock falls. Okay. If x is more than or equal to 2 and the topmost rock falls, then there is another probability that the second topmost rock also falls. And okay, so yeah, okay, I see. There is a probability that we like have a chain reaction of falling, basically. If the tower successfully reaches height of n without any rocks falling, then the game is ended, and we need to calculate the expected value of the number of moves. Okay, this is the probability theory, which is better in my opinion than the combinatoric stuff. I don't like the combinatoric stuff. So I feel like this should actually be easier, right? What is the n? 2 multiplied by 10 to 5, all right. And then p is up to 99, all right. So the So this is a dynamic programming problem. We are going to calculate what is the expected value to reach the end. What is the expected value of the number of moves that we're going to need to do if the height tower is currently like specific value, and also on the current move a certain number of rocks have already fallen, basically. Yeah, that's pretty simple. Let's just make sure that we don't. Yeah, see, like in the other problem, the memory restrictions was of 256 megabytes. In this one, it is 512. So, like, can I do my stuff better? Is what it means. Let's do m.rs. Yeah, I feel like this is so much easier. Oh wait, hold on. No, 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 no. I did it wrong because I thought there's at most like 99 rocks that can fall, but that's not true. Okay, what I know though here is that the probability that we're going to fall is never 100%. I guess it makes sense, it just means that the game is like has the probability of finishing. So what's our stuff here? How many turns do we need to is expected if the current height is this? If the current height is this. And we are doing one more turn. And we are doing one more turn. Then, well, hold on. The it's not even dynamic programming because it's like recursive here, right? You can go back to the same height basically. Again. So the formulas here are something like this. The probability when we have the current height of h, right, is going to be like p. So like the probability that the first one is going to fall. So like the probability that the first one is not going to fall. So like then it's going to be the number of turns of height plus one, right? I mean, we just do one turn, and so like, yeah, we do one turn, and then we have the expected probability of the other things. So then we add the probability that the first one falls, and in case it falls, then we have like well, basically, I feel like if we do a two-dimensional dynamic programming, in terms of LeetCode, difficulty is hard. Yeah, I think difficulty is much harder on Codeforces than the LeetCode. Okay, let's do dynamic programming where the current height and how many rocks have fallen already. So like falls this. The probability that the current rock is going to fall. And if the current rock is not going to fall, then we have the height plus one. Otherwise, we do probability that it is going to fall. And in this case, we are going to have height minus one, but we are going to have falls plus one. So something like this is the formula. And I guess we only add this if the if the height is 0. So like, I mean, but almost like this is our formula, right? So sometimes we go down height, sometimes we go up the height. This question, I don't know. I only did like 10 LeetCode problems, so I can't really know. But from what I heard, the I mean, it's like, I don't know, it's different. LeetCode is mostly about just like implementing, maybe, and this one is more about thinking. No, but maybe not. How many problems on LeetCode about the probability theory have you seen? So in this case, we reset the number of falls. In this case, we do that. So the problem is that this function is recursive. Sometimes, yeah, it's not like really dynamic programming here. Because we can go back to the same height. Oh, wait, hold on. I know what it is. In order to not make it recursive, we need to figure out. So like, let's say that the current height that we have is like h, right? And so like current is h, right? And we want to figure out the expected number of turns required to reach height plus 1. Right? So like, what is the expected number of attempts that we need to do in order to reach height plus 1, you know? And in order to reach height plus 1, we need the first rock to not fall, right? And in case it does fall, then hello. In case it does fall, so like, we want to figure out the expected number of turns to like go to the next level, basically. And while doing that, we basically already know what is the expected number of turns to go from like 0 to whatever height, including the current height. But after we calculate the expected number of turns to go to the next turn, we already know basically the expected number of turns to go from 0 to the thing, right? Okay. Yeah. Okay. So if I want to know how many turns it takes to go from every single height to the current height. Like, let's assume that we know that, right? After we calculate the expected number of turns to go to the next level, we basically are going to add that expected number of turns to every single value in the current like array, because in the current like array we're going to maintain the expected number of turns to like reach the current, and we are increasing the current by 1, so we are adding that number to everything, you know? So that's the thing. And then in order to calculate the expected number of turns to go to the next level, let's call this value f, right? That's to go to the next level. It's going to be either the first one stays, right? So it's going to be this multiplied by, so like we do at least one turn, and then we, in case the first one does not fall, then we do 0, right? And then so like basically I want to okay, basically we are, so in this case 0 stones fall, and in case of this 1 stone falls, but if But in case the first stone falls, there are still two variants, right? Either the second stone doesn't fall, so like this, and in this case, the number of steps is going to be like the number of steps to reach the current height from the current height minus from the current height, which in this like the expected number of turns to reach the current height from the current height is 0, obviously, but still, like for this to be generic, I feel like because in case 2 stones fall, then we would need to like multiply something by the expected number of steps to reach current height from current height minus 1, you know, and we multiply this by probability of us losing 2 stones. Yeah, I feel like we can do something like this. So the expected number of turns to go from current to the current multiplied by the probability to lose 1, you know, and if we lose 0, then we just take 0, right, turns. Oh wait, hold on. In this case we just do 0, and in all the other cases we are going back to the current, and then after going back to the current, we also add the expected probability to go to the next level, which is what we are like currently solving. So this is still a recursive formula, is the thing, right? And then etc. So like current minus 2 for losing 3. But it's the formula with only one unknown variable. Which we can move to this side, right? So instead of adding that here, we're going to like subtract here. So like 1 minus lose 1 minus lose 2 minus etc, you know? So we want to basically know okay, so I feel like right now I have like a quadratic solution to this, because I can calculate this in linear time, right? But this is like a progression that I feel like should be done in one turn. Okay, maybe it's not that easy. Maybe it's not that easy. Maybe I'm close to the solution, but still. Let's just read a couple more. Let's read this one too. Imagination Castle. Given a chessboard, n times m, and rows and m columns, each row is numbered from 1 to n from top to bottom, and each column is numbered from 1 to m from left to right. The tile in a row R and column C is denoted as RC. There exist k distinct special tiles on the chessboard, with a special tile being tile X, I, Y, I. It is guaranteed that 1, 1 is not a special tile. Alright. A new chess piece has been invented, which is the castle. The castle moves similarly to a rook in regular chess, but slightly differently. In one move, a castle that is on some tile can only move to another tile in the same row or in the same column, but only in the right direction or the down direction. Okay, I see. Basically, we can move only right or down as many cells as we can. And then we're playing a game. In the beginning of game, there's a castle in the tile 1-1. The two players will play alternately, with Chineki going first. In one turn, the player must move following the rules of the castle. If the player moves to a special tile, then the player wins the game and the game ends. Okay, so the goal is to win the game. And on your move, you want to move to the special tile. And the castle cannot be moved. We lose. And we cannot move only in the case we are in the bottom right corner of the board. Okay. This one sounds easy, but is it actually easy? I guess the hard part about this is we cannot do dynamic programming because the restrictions are too high. Okay. And the next K lines, yeah, okay. We just have at most 10 to 5 special tiles. Okay.
Squiggly rings.
Yo, hello, Rings. I'm solving some competitive programming problems today. Am I playing chess? No, it's like the problem about people playing the chess, and like I need to. It's like a puzzle. It's like a programming puzzle, basically. These things, and I'm solving the hard ones. I have solved so far. I'm like doing a contest, and so far I have solved 1, 2, 3, 4, 5, 6 out of this contest. So like, the further we go, the harder they get. which means that I'm just going to be thinking mostly here. Right. There has been one problem that apparently is easy, but I have not solved it yet. Maybe I need to go back to that one. Let's see. This one has been solved by a lot of other people. And this is not chess. This is like math, combinatoric stuff, which I don't really like too much. We have sets of integers in this problem, and two sets. One set of it is a child of the other one. If you add 1 to each number, and you get the second one, and you can also like insert new elements into the second set, and all the integers should be from 1 to k. And then you need to find the number of different arrays containing n sets of that shit. Can also try reading a new one. The other ones are solved by even less number of people, so they are supposed to be harder. But we can at least read them. We have 1 hour left. I'm probably solving only one more problem here. Keen tree calculation. There is a tree of n vertices and n minus 1 edges. There is ith edge connects this and this and has the length of this. The owner of the tree asks you q times. The question format is, if each edge that contains vertex x has its length multiplied by k, what is the diameter of a tree? The diameter of the tree is the maximum possible distance between two different vertices in the tree. All right. Wait, how do you even calculate the diameter of a tree? Between two different vertices? I don't know. This one sounds hard. What about this one? Jackets and packets. Pack Chanak has n jackets that are stored in a wardrobe. Wardrobe has enough room for 2 stacks of jackets, namely the left stack and the right stack. Initially, all N jackets are in the left stack, while the right stack is empty. Initially, the ith jacket from the top of the left stack has color C, I, and then we want to pack all of those jackets into some packets. Such that the jackets in the same packet are the same color. However, it is possible for two jackets with the same color to be in different packets. We can do two kinds of operations. Any number of jackets from the top of one stack, as long as the color is the same, and then take those jackets out of the stack and pack them into a packet. The packing operation takes X minutes, no matter how many jackets are packed. And then we can move one jacket from one stack to the top of the other stack. And this takes Y minutes. Determine the minimum time to pack all jackets. $400 is the number of jackets that we have. Determine the minimum time to pack all jackets. So hold on. Can we reorder them somehow? We are doing them one by one. What can happen to our stacks here? We have like jackets like this, right? So when we are taking one from here, putting it here, you know, this one, I don't know, we can do 1, 2, 3, 4, 5. So we can like instead take this 5 and make it here. 5, 4, 3, and then 1, 2. So like the right stack is going to be like reversed, and then if we go back, we like don't really change the ordering. It's just like with the left stack is the forward order, and the right stack is the backward order, basically. I feel like the only thing is, that like if we pack this one and then move, then it's going to be like no longer a subarray because we can like move this one back, and it's going to be 1, 3 instead. The thing is 400. To the third power looks like it's good enough, but I think it's we do the fourth power, then it probably is too big. So like our complexity should be like cubic here. But if we do that, like why would we ever do that? The only reason to do that if we want these two guys to be packed into the same thing, right? So like my current theory is that we do like dynamic programming again. Why is everything about dynamic programming? Or maybe it's not. So like we have these jackets from the bottom in the left one, and we have this many jackets in the right from the top, and we are going to either do just reordering, um, we are either going to do reordering, right, or we are going to do the packing. Well, no, if we just reorder, then it's something else. Okay, I don't know. This one is hard. Okay. What else have I not read yet? Elevators of Tamam. There is a building named Tamam Membaku. The building is N floors, numbered from 1 to N, from bottom to top. The only way to move between floors in the building is to use elevators. There are 3 elevators available in Tamam, namely elevators 1, 2, and 3. We work as the elevator operator. We will work for Q days. Initially, each elevator is in floor 1. All elevators are on. On each day, exactly one of the following will happen. There is a person currently in floor X who wants to go to floor Y, or the elevator changes the state of the start of the day. If it previously is on, then it will turn off. If previously is off, then it will turn on. Okay. For each day, we can control the movement of all elevators as we please. However, for each day, however, for each day where there is a person currently from floor X who wants to go to floor Y, among all elevator movements, the following must happen. One elevator moves to floor X. Person gets into the elevator moves to Y, and the person gets out of the elevator. I mean, it makes sense. For each day, we can only move the elevators that are currently on. Note that since a change in state happens at the start of the day, it means that an elevator that turns off on some days starts mean that it turns off on the some day starts becoming unusable from the day itself. Conversely, an elevator that turns on some days starts becoming usable from that day itself. It is known that the electricity fee for each day is different. More specifically, on the J day, the fee needed to move the elevator up or down one floor is this. From the start, we already know that the electricity fees and the sequence of the event that will happen on the Q days, so we will operate strategically. What is the minimum possible electricity fee to fulfill all the needs of all the people who want to move between the floors? Note, in the end, each elevator does not have to go back to floor 1. Number of floors and the number of days is this. The electricity fee for each day. Number of days is 300. So This could be done with dynamic programming if the number of floors were not that big, because on each day we just need to know where each thing is. But that would be 10 to the 15th multiplied by 300, which is a lot. And is it possible sometimes that it is impossible to move the people because all of the elevators are off? That can happen, right? Technically. Minimum possible is the fit to fulfill all the people's needs. So like it's guaranteed that it's possible, I think, right? Okay. Well, I immediately see one of the optimizations, and it is like when I am on the day Q. When I am on the day Q, one of the elevators, the one that is going to move the person on this day, is going to be on is going to end up on the floor where this person like goes, kind of, right? So we know where one elevator is going to be, at least. That can divide our complexity by 10 to 5. Still a little bit too much though. Or do we need to 10 to 5 multiplied by 300, I guess, and maybe also by a logarithm on top. Well, hold on. Hold on. Hold on. There are n floors, but we do not need our elevators to ever be on a floor on which does not happen in the input. So technically we don't actually have 10 to 5 floors. We only have 300 floors that are important floors. Right? So this means that the most stupid thing would be 300, so like Q. So like where is the first elevator? One of those Q things, right? When is the second? And where is the third one? So Q to the cube power. And then also to the fourth power because of what day it is currently. Right? Let me see. Python, no. 300 to fourth is too much, I'm pretty sure. We need to do to the third. To the third, it seems like a little too small. We can do something else because the time limit is 5 seconds. But maybe I'm just doing this Not necessarily. I'm even like overestimating here. Hold on. So we need to know where the first elevator is, where the second elevator is, and where the third elevator is. Technically, we can keep them sorted. And if we keep them sorted, then we can like divide by 6, I guess. Ah. Oh, wait, hold on. I also just realized we are turning off and on a specific elevators. So the elevators, we cannot like we need to know which one is first, which one is second, which one is third. So I feel like we need to like know what is the last person that was moved by the first elevator. What is the last person that was moved by the second elevator? And what is the last person that was moved by the third elevator, right? And judging by those things, and then based on those things, we can we basically know what is the last person that was moved, and we need to move like the next person based on that, right? Hi. Hello, Tulkas Codes. Hello. We're doing Code Forces today and not Lit Code. In case you're interested, this is the contest that I'm solving, one of the past ones. Feel like I know how to solve this problem here, even though this one is like one of the hardest ones that I have not solved yet. And it's pretty easy. We just need to know what is the first, what is the last person moved by the first elevator, the second elevator, and the third elevator. So we need to move the next person. You know, to start doing Code Forces again as well. Yeah, the last time I did Code Forces was 10 years ago. Yeah. I'm solving the past one, obviously, not the one that's like currently going. There is no currently going constants anyway, probably. What's there in the future? There is going to be this thing in the, but I cannot even do this one because like, what is my current rating? My current rating is pretty high, so like I need to wait for the Div 1 contest, right? But I don't think that I can, because Div 2 is going to be unrated for me, right? I don't remember like what is Div 1 exactly. Gennady still on top of 10 years later, but he's like, he's professional competitive programmer. Is he doing anything other than solving competitive programming tasks? Like, what's his job? Because I feel like that is his job. He's just like he's just getting money by winning competitive programming contests, or is that not so anymore? All right. So once again, yeah, okay. I feel like I know how to do this one. I feel like I know how to do this one, but maybe I will realize that I'm wrong a little in a little bit here. Let's see. What do we need to do? The first one is N and Q. Google ended Code Gem. Yeah, the Google Code Gem, I remember that. I didn't really participate much. Like as soon as I ended my competitive programming career by like I did the world finals, but then after my last one, I never really did competitive programming much. Electricity fee for each day, and we need to do the minimum possible electricity fee. And I feel like 10 to 5 multiplied by 300 multiplied by 10 to 5, yeah, which is definitely a 64-bit that we will need here. The jth line of the next contain jth event described. Okay. So for j in 0 to q, we are going to read the event. So it's either one event that this person needs to go there, or it's two. Okay. Okay. Okay, so the type is either 0 or 1. I guess we can do it without parsing here, actually. I can just do the match. This thing, it's either 0 or it's 1, right? Otherwise, it should be reachable. Okay, so those are the two types of the events. And I feel like when we go from the previous person moved to the next person moved, what we will need to know is on what days can we move this elevator, basically. On what days we can move this elevator, and we are going to move this elevator on the day with the smallest electricity fee among those days. Okay. Okay. Anyway, let's see. Person X and person Y, right? X. I mean, this is floor, right? This floor. I'm just going to do U64. Parse next. Parse Okay, and in case of the second type of event, we just want to know the elevator that is going to be turned off or on. In 0 indexed. Okay. So now that we know that, okay, I feel like the solution is actually like super simple. Here's what we're going to do. I'm going to do the breadth first search. Oh wait, hold on. It's actually not BFS. That's the thing, right? It's going to be the well, I don't know. Actually, I feel like I want to just do the lazy approach that I was doing before. Let's just make sure that we don't run out of memory again like we did in the other one. So we're going to use 300 to the third power, and in everything we are going. So this is the number of megabytes, right? And in every but in every single entry we're going to store the answer, which is going to be 8 bytes for the begint, and then the key is going to be so like 8 bytes for the answer, and then like if we are doing a hash map style, then it's going to be the key is those 3 U sizes basically. So it's like also this, right? So this is going to be 823 megabytes, which is too much. All right. Okay. What else? How else would I do that then? I mean, technically, I don't need 8 by 3 here, right? Like, if I do my key to be smaller, I need 2 bytes to encode a number up to 300, right? So it's just going to be this, and in this case, we're going to have enough memory. How much time do I have left? I have half an hour. I need to solve this in half an hour. I'm pretty sure I can do it. I just need to like figure out this memory part because this seems a little like sketchy. Can I do this without like the recursive and memorization stuff? Can I like save on the memory somehow here? I would. $512 megabytes is what we have. So this can be like dynamic programming or like something like Dijkstra, A star kind of thing. Hmm. Well, I mean, hold on. Let's just do the array stuff then, right? like just to be sure, we are just going to do the array stuff, because we are just going to not store the key at all. We're just going to index that, right? So we're just going to do exactly 8 bytes for every single like thing there, and this is only 200 megabytes. Like that's like the stuff you would do in C anyway, right? So yeah. Okay. How do I write this? How do I write this? Recursive. No, I want, yeah, let's do recursive one. Okay, let's do something like we're going to do this the same. We're going to have a struct solution, and then we're going to have a recursive function here. We're going to solve like where is the first elevator, right? So like where are the elevators, right? Where are the elevators? It's going to be 3 optional index of a person that was moved last, basically, right? That's all I really need. So like originally we're going to do the solving where the all of the elevators have not moved a single person yet, right? Only no one has moved a single person yet, and this is going to return me the answer, the cost, the minimum cost. All right, so first of all we need to figure out what is the next person that requires moving, right? That is one of the things that we are going to need to like pre-calculate, I guess. Yeah, so we're going to know next person is going to be basically just a back of the index to the next person. Optional, maybe. Just do this. All right. So, so yeah, the next person that we're going to move is let's see. So first of all, so like the last person that has been moved is the maximum of those things, right? So W into iterator, then we flatten, right? And then we find the maximum one, and then we unwrap, or 0. I guess not unwrap, but we like map or 0. And in case there was a person that like the last move, then we want to do last plus 1, right? So that's like the first index where we start. We need to start looking for the next person, right? So we get self next person at that index, copied, unwrap, or none. Okay, so that's the next person, which is so the next person has been determined, their index, right? That the next person that we're going to move, and if next person if next person is nothing, so if we don't want to move any more people, then we don't need to use any electricity at all, right? So we're going to just return 0 as our answer, right? Otherwise we need to figure out what is the elevator that is going to move that person, right? What is the elevator that is going to move that person? Since the last person that was moved is that other person. Okay, let's just do a for, right? For index of the elevator and previously moved person in w into iterator enumerate. Okay, so we are trying to move the next person using the elevator I, right? So we know where the elevator ended up after moving last person, right? So let's see, previous location is going to be it's going to be the events. I guess let's just, we did not end up doing this thing. So like this is the event that happens on this on a day. It's either a person who moves from this floor to that floor, right? Or it's toggle the elevator of this index, right? So in this case we do events push event toggle of this elevator, and this case we do event person from X to Y. Okay, the events is a list of events. All right, sounds good. Now we want to know the previous location. It's either the previously moved person, or if we previously did not move a person, then the floor that we start at is 1. But in case we did move the person before, this is based on the index. In this case, we get the event. Let's have events here, I guess. Events that we know about. Events at that index. This event is obviously event that is person, right? And person was moving from, no, we don't care where it moved from, but we want to know where it moved to, so that is the position that the elevator is actually at. All right, so now that we know our previous location, which is the floor, right, the next location that we need to move to is events on the next person. So like we are trying to move the next person and we want to know where the next person is going from. We don't care where it's going to, right? Actually, we want to know that anyway. We want to know the next location, next person from and next person to is what we want, right? We want both of those to get retrieve. All right. Now we want to move the elevator from the previous location to the next room, right? In one of the days in between the previous day and the next day, right? So so basically we want to move elevator number I from the previous location to the next from location. I mean, we don't want to move the elevator. We want to find out the minimum cost day for the elevator I in between, including the days previously moved day or 0 if they did not move anyone before, and until and including the day, which is the next, right? Yeah. So minimum cost day is the minimum cost of the electricity on one of those days. So like we use that cost. This cost should be like doable, obviously, right? So this, it looks like this one can be an option. So like if let sum in cost is this means that we can move the elevator like at all, right? So if we can move it, then we do I don't know, let's do map here, by the way. I rev moved, because the reason for that is actually filter map is what we're going to do, because we're going like in case this is none, where it's not going to be movable at all. Because out of all of the options of the elevators, I want to find the best option, right? So the minimum answer is what we want, and that's our solution here, basically. Minimum. Do we return optional here? I don't know. Yeah, let's return option. Nah, I know. Let's unwrap here for now. And that actually is our answer. But we need to. We'll need to add a memoization on top of that, obviously. Okay. So minimum cost day. We are going to map that. If we have found this day to, so like we are going to use this mean cost to move the elevator from the previous location to the next from location. So we're going to use the absolute value. Oh wait, hold on. There's the absolute diff. Previous location, absolute diff to the next from, right? So that needs to be done using the minimum cost, and then also we're going to move the actual person. So in order to do that, we also need to we also need to move that person on this day, obviously, right? So like next from difference with next to, right? And this should be moved using the electricity cost on this day, and we need to just check that this elevator is usable on this day, which it should be, right? Yeah, so like if not self-usable elevator I on the next day, basically, right? Then we return none here. Okay. And over here we use the electricity cost on the next day to move the next person. All right. Okay. Electricity cost is a list of integers. What else do we need? Usable is going to be the like, is the elevator usable on this day, right? Yeah. Something like this. What else do we need? How much time do I have left? I feel like I'm doing it slowly. 12 minutes, oh shit. Okay, well, I'm getting there. Hold on. Usable. What else is not compiling yet? Min cost day. Okay. Min cost day. Min cost day for the elevator I, and between the days from day this to including day this, right? And this is going to return me the optional minimal cost, right? Okay. Is that it? Well, we need to calculate the minimum cost day, and we need to do the usable here. And we also need to calculate like the next person, right? Next person for, which is basically like for every day we want to know the next person. All right. So let's see, how do we calculate the next person for every day? We go so like the next person, we go, first of all, we go none of the queue days, right? But we go for event in events in the reverse order, enumerated, right? For day and event, and we say that if let event person to be the event, then it means that the next person for this day is going to be equal to this day exactly. Otherwise, the next for this day is equal to next get for the next day, unwrap or default, unwrap or none, like that. So this one should be sum, and this one should be copied. Okay, so this is how we calculate the next closest person. Programmer Jeff, hello, hello. This is how we calculate the next person who we need to move starting this day. Okay, and then usable, we need to calculate if the elevator is usable on this day or not. And in order to do that, we do okay, well, we do std array from fn. So for every elevator, for every elevator, we are going to calculate if they are usable on this day or not. So we're going to do back from well, hold on. We just need to do events, iterate, not reduce, old. Do I like reduce. Fold, like something similar to fold is what I want. Whatever. You know what? We're just going to do result, like usable is going to be vec of I don't know. Just do a vec new, and then we go for event in events, right? We're going to match, and if, I mean, just do if event is toggling the elevator P, right? So if this event is us toggling the elevator P, so originally the elevator is usable, right? But once we are toggling, we say if P is equal to the elevator that we're currently like calculating, and we do current is like we toggle it literally, right? And then we just do usable push the current thing, and then that's the stuff. Okay, so we have calculated it now. We have calculated it now. Now what is remained to be done? Now what is remained to be done? We need to do memoization, right? So we need to memoize two functions, the f, and then this is also going to be lazy, I think. This is going to be a ref cell of how do I do this? Hello there. Hello there. I have so little time. Can I do this in 5 minutes? I don't think I can do it in 5 minutes, but we're going to be very close here. So the thing is, let's just do the hash map. Let's just do the hash map. Okay, hash map. The thing is, give up. No, not give up. Hold on. Why would I give up? I mean, I can just solve it and like after the time is over and see if it's correct or not, right? Okay, let's just do vec of u64. We're just going to like need to populate this correctly. All right, let's see. Memo f ref cell new. So we're going to do vec of 64 max, which is going to mean that we have not calculated it yet, and the thing is going to be q plus 1 power to the power of 3, because that's like the thing that we want. Okay. All right. So now we are going to calculate the e, the index. Let's calculate the index, and it's going to be 0, and then we do for w and w. Index is index multiplied by self events length plus 1 plus w unwrap or self events length. So like we do like the funny index calculation here. So then we do if self memo borrow at the index is equal to u64 max. This means that we have not calculated it yet. So we are calculating it. We're doing borrow mute at the index to be equal to the result. And then we return at the index. Okay, so now we have done memoization of that. And the only thing that is left to be done is min cost day. So this is me calculating the minimum cost for the elevator I to go like in between these days. So I out of all the usable days, I need to calculate the minimum cost, right? I'm going to do just the same, but this one can be done using a hash map. Memo cost is going to be ref cell of a hash map from size into 264. Yeah, sure. This one is like much smaller, so we can do a hash map here, which is easier. Okay. So E is going to be I from and2, and if not, this contains the key, then we're going to calculate it, and then we're going to return it. And over here, borrow mute, and then we insert at the key and the value that we're actually like calculating, right? So what are we calculating here? So what are we calculating here? So like if self usable, this elevator on the day from, hold on. So like it's either usable or not. Okay, coding is finished. All right. I am not fast enough, but let me finish this. I feel like I'm really close. Even although this problem is like was supposed to be harder than the other ones. I guess it's harder, like judging by the number of lines of code that I have written here. Let me just see if I get it correctly here. If we are usable, then I can use the electricity from the day from, right? And then also we potentially can use the electricity from the remaining days. So like, but only if 2 is more than from, right? Then it's multiple days. Then we can do calculate the minimum cost for the same elevator, but from like the remaining days basically. So those are the options, and we find the minimum. Value, right? And that's our result. I feel like that's it. Then sum, if is what I want here. And over here we also do, over here we just do it lazily, I guess. Minimum exists for in into iter u64 into iteration u64. Wait, what? Oh, not then. I guess I need to do a flatten here. Do a flatten here, and then it should be good. All right, so now we have calculated the result, and we are inserting. So the value here is actually optional that we are going to. Okay, that is done. right? That is done. So cargo run, this is the problem E. Okay, some of these are unused for whatever reason. Why is N unused? What is N? N is the number of floors, which is literally like why would we use this? This is correct. Like this is not used. And then also we have unused variable J. Yeah, we actually don't need that too. Anyway, here's our input. Let's just save the test. We have only one test. Tests E1. Okay, we have panicked. Panicked because assertion failed, because we did not read everything properly, apparently. Oh wait, it's actually 1 and 2 and not 0 and 1. So like 1 is moving and 2 is the toggling of the elevator. All right. The answer is 18 for me, and the answer is actually not 18. Okay. Which means that I did it incorrectly. I did this incorrectly. Answer is 18. Let's see how I calculate this again. What did I do wrong? So we basically have 3 elevators that have previously moved these people, right? So we are basically seeing who is going to move the next person, right? Who is going to move the next person. If there is no one else who we need to move, then the cost of doing that is 0, right? Otherwise, we need someone to move that person, right? So we are trying one of those elevators to move this. Previous location. Am I calculating the previous location correctly? So like if we did move someone previously, then we are on the elevator that the previous person moved to. Otherwise, we are at the floor 1 in the very beginning. And then the next person is going from this to over there, which means that we need to move the elevator from where it was before to where we need to move the new person from. And we can use any day that we want for this, right? We can use any day from the previously moved person day to the next person day that we're currently moving, including both of those, okay? And then we use that cost to move from the previous location to the next from, and then we move from the next from to the next to using the cost on that exact day, which seems like this part is correct. The minimum cost day. If it's usable, then we can do here. Otherwise, we get it from the other days. Well, I mean, one of the things that we can do is we can like figure out some of the partial values. We can construct a smaller test case, I guess, right? Let's construct a smaller test case. What do we have here? The number of floors, 1 billion. And then the number of days is going to be 1. So let's just move one person. We just move one person from floor 1 to floor 10. Or like from floor 1 to floor 2, and we only have oh, the second line contains the cost of the electricity. Okay, so let's say that the electricity costs 10 on this only day. All right, so that should be the test case. So for this one, we need to do 10 electricity because we need to move this person like just once, right? Let's then move this person from like 9 floors, then the answer should be 90, right? If we move it from 5 to 10, it's still going to be 90, right? Yes, okay, so moving one person is like working here. What about toggling? So if I toggle the first elevator, and then I toggle the second elevator, and then toggle the third elevator, it's actually going to not work, right? We need 4 days, 10, 10, 10, 10. It is still 90. Okay, so this is incorrect for sure. This is incorrect for sure. Wait, hold on. All of my elevators are turned off. This should be like unsolvable. So we should have unwrapped here and panicked, technically, right? We should have unwrapped and we should have panicked. Let's see. Let's see. Let me print out here. Let me print out here the W and the result that we got. Right? Okay, so when nothing, it is 90. Okay. Let's do the min cost day, right? Min cost day should be. Oh, wait, hold on. So hold on. Usable? Maybe usable is incorrect. Usable. Usable. The third elevator is usable on the last day. Did I hold on? The third elevator is usable on the last day. How is that so? Because I have turned them all off. Okay, that thing is incorrect. Where's my bug? Oh wait, did I remove one from the index of the elevator already when I was reading the input? Yes, I did. Okay. Yeah, okay, that is why. Because I needed to, yeah. I need to add one here then. Okay, and now we are unwrapping actually. Okay, so that's good. So that's good, and then the test case 1 is 18 still, which is still incorrect. Okay, which is still incorrect. So let's see what else is wrong then. So this is unwrap because we cannot solve this, obviously, right? Let's do without unwrapping. We just do result, unwrap, or 264 max -1 because that's going to be our like secret value. We're doing none. Making the window manager work so smooth on macOS is a pain. I don't know. I mean, I used macOS before, and I don't want it anymore. But I don't know. Probably some things have changed in the last 10 years of macOS. Okay, so answer. is unwrapped. So like we assume that the thing is possible, right? Okay. So for this test case, obviously it is impossible, but what I wanted to do is like to toggle them. I don't know. What am I supposed to do here? It's like if I don't toggle one of them, then the answer is going to be 90. But at the same time, if we make on the first day the cost is going to be 1, then we go the first 4 using 4 cost in total. Yeah. Okay, this sounds good. All right. So what's the actual test case that is not working? I mean, the original test case. Where do we go wrong? Where do we go wrong? I feel like I need to like print out the things and see where is my bug here. Wait, I only move one person? Oh, wait, hold on. I see it. I move one person, but I never like call the next things, right? So like this is the cost to move this person, right? But after moving this person, I also need to move the other people, right? So we are going to add cost, which is this, where the new elevators, so like we have moved the elevator I to move the next person, right? So this is the new arguments, and then we use that, and yeah, and we add the cost of moving those people, basically. Okay, and now the answer is 114. Okay, finally. Okay, I just missed one little thing here. All good, all good, all good, all good. Let's just try and submit this. Can I submit this still, right? I think I can. After things are over, this is E. Okay, hopefully I don't run out of memory or some shit like that. How much time is it past the end of the contest? I feel like I was like so close to doing this in time. Oh, hold on. Exceeded time limit? No way. 5 seconds. My solution takes... Why would this be time limit? We have 300 to the power of 3, and then inside here I calculated for... I calculate stuff. So this is like this all one here, right? The only thing is the min cost day here, which we also do memoization here. So this is like 300 squared. Is it because like I didn't just optimize stuff? Why haven't you learned Rust yet? What the fuck is wrong with you? I don't know, what's wrong with you? You should probably go and learn Rust like right now. Why would this be? The time limit exceeded. Memory I'm using is this, okay. You only use Haskell? I don't know. Maybe you don't need to learn Rust actually. You know, since you're already doing Haskell, there is one language that I'm kind of excited about, which is called the anti-lang, which this is like more functional and being low level at the same time. So like I feel like if this is going to actually be done, this is right now in active development. I feel like this one can be pretty good. At least like this sounds like this is what I want. So this is a language that is going to have a refinement types, lifetime inference, and algebraic effects. This one is like my favorite feature that I want to see in the next language. Low level FP is the dream. I wonder what the design philosophy is there. I don't know. Also, like, I don't know. I can just like show you something like the algebraic effects, or what do we have here? Like for example, the allocator effect, right? So like in languages like C++, you don't like in Rust you can configure your global allocator, but you sometimes want to configure like the local allocator. So like using the effect system, it can be like really cool. A way and easy way to do that too. But it's like the low level, but it's good. The same stuff can be used to like high level to implement like async await using effect systems and stuff. Rewrite Linksider in anti soon. No, I don't think it's going to be happening soon. I'm not even sure if their compiler is like working yet or not. They only have like the idea on paper, I think, so far. So like you know how yeah, and like if we talk about like that allocator stuff, like languages like Zig that or I think they make the allocator be like the explicit argument of your like constructors or something like that, right? So that's how you do it. But like the effect system is making it implicit but also controllable at the same time. It's like an implicit argument to functions or something, you know? So like it's more usable than the Zig approach, and more configurable than like the current Rust approach when you can only like configure the global allocator. Um, anyway, doesn't matter. In my brain, low level is sort of synonymous with referring to a RAM machine model. And you see the declarative nature of FP is sort of divorced from that. Describe how to compute, not what to compute. I don't know. I didn't really do like a lot of Haskell. I don't think it's that different. The only thing is like everything is immutable, which is something that I actually don't like. I'm not sure about the anti-lang if they are like doing all immutable, because like sometimes you want to like describe your actions in terms of mutation. I still at the same time want the mutation to be like really like controllable. It's like you cannot like mutate the outer world, you can only mutate the local arguments of your function, for example, you know? Or so like in Rust, for example, you can give give a function a mutable reference to something, right? But it's still like your function can still do a lot of things, like, and I want even more like control and more restrictions. Haskell has what essentially amounts to mutation via monads. Yeah, but that's I don't know. From what I have seen, it's meh. But then I don't really like have much experience. But the Haskell, like the language of Haskell, is simple, but I don't know. I feel like the approach to the mutation that you have in Rust is better. You can just do shit in the IO monad for real mutation. Yeah, but like that's like allowing you to do too much. So I don't want to do that. I want to have precise control of what is going to be mutated and what is like what is allowed to be done, what is not allowed to be done. Anyway, hold on. I'm doing time limit exceeded here, so I'm not sure why is my stuff so slow here. Is it literally because I'm using the ref cell? Hold on. What if I just, instead of using ref cell, use the unsafe cell here? Is that the reason I'm being slow? Because like I spent time checking for this stuff. We prefer PHP kappa. Well, that's a big kappa. I mean, PHP actually like is not that bad. I did something in it not so long ago, and it's a lot better than I thought it was. I think PHP is better than Python, and it's better than JavaScript, for example. Is the official Rust book still sort of the recommended way to learn it? I think yes. This says Davey. Davey, did you actually read the Rust book? Hold on, Davey. If you say, hold on, Davey. When are you going to Python with types is pretty nice. Yeah, but a lot of things are not using types, I feel like. I mean, maybe if everything was moved to be using types, then it's like nice. From what I understand, a lot of things in the standard library are not using types. I've actually read through, I forgot it all, and I remember getting hung up on ownership stuff. Also, no global interpreter lock soon. Yeah, I do know that they have like generics in the latest Python, right? So you can like do a lot with types there. For ML, there is little other choice other than Python, C++. I'm not sure how good it is in Rust because I'm not doing machine learning, but there is this thing that's called Burn library in Rust. So this is the deep learning framework, and I don't know. People said that it's like kind of easy to do, but I mean, obviously the like the Python like PyTorch stuff is like more, is like there for much longer, so they probably have more features. I don't know. Like I'm not really doing that. Euroaxi and Yag, thank you for the raid. You guys both. What are you guys doing? I'm doing some competitive programming. We just finished the contest that I was doing on Code Forces here. There is one problem that I almost solved in time. I think my solution is correct here, but I feel like I just need to optimize it a little bit because the time complexity I feel like should be good here. We are pulling our respective hair out. Nice. So you still have hair. That's good. Twitch integration sucks. Which integration of like what exactly are you integrating? You doing like that Twitch bot? Interesting. It uses this Rust bindings to the C++ API PyTorch. Yeah, I think from what I have read, this machine learning, this deep learning stuff in Rust, it has multiple backends, and one of these backends is like pure Rust, but you can do a PyTorch backend, or you can do a web GPU backend, which means that you can do like in browser stuff. You can have Candle backend, whatever that is, and the array backend. I think you can do like pure CPU stuff, or you can use PyTorch, or you can use WebGPU. There's like multiple backends for this library, basically. There you go. I'm here at so I'm going to have Raiden, right? Have a good one. Good luck winning the Rust. Thank you. Plan is all of it at the moment, just IRC. Working on this Stream Deck Ask program. Okay. Sounds pretty cool. Sounds pretty cool. We have these crabs in the bottom of the stream, right? This thing is the custom stream overlay, also written in Rust. So that's where I am using the Twitch API a little bit. And it's just like some stupid commands like a jump scare over here. Fortunately, ML researchers' code suck usually. I doubt people will switch from Python soon. Well, a lot of people will. Like, you know, people are still doing Python for a lot of, like, I don't know, backend stuff, for example. I don't understand those people at all. But there are still a lot of people who are doing that. Anyway. I need to optimize this just a little bit. I feel like my solution is correct. Let me open my tabs back. I'm solving this problem here. Add out yourself. Alright. See you. Thank you for the raid again. You actually find Python 100% unwritable. Yeah, I mean, there are types in Python these days, and you can use those, and they make your code a lot better readable and everything. But yeah, it's still. I'm not sure if it's there. Yeah, I want more checks, and I want, like, for example, in Haskell, one of the things that I don't like immediately is like some of the, like, the exception stuff. Like you can very easily like cause an exception, and I don't want it to be there. Like I want like to be able to disable the exceptions completely. Same in Rust, we can panic, and I want to disable the ability to panic sometimes. And I feel like the algebraic effect system is like there for it. I can't wait for the algebraic effects to be like mainstream. I don't understand why would you do a project of any size in Python. The extra overhead of designing data types is easily amortized. Well, I mean, I can understand it. It's because Python is very easy to learn. I still think I would advise people who are learning programming for the first time to learn Python instead of Rust or Haskell, because it's like easy to get started. It's just you just don't want to be maintaining stuff written in Python. And eventually, once you learn some other languages, I don't want even to write code in Python that I even don't want to maintain, really. But still. I think I understand why Python is popular. It's because it's easy to learn, it's easy to get started with. All right. Okay, I have solved this problem, but we have a time limit exceeded. I wonder how much time is like actually exceeded. How much time are we actually exceeding here? That's not a good argument for doing serious projects in Python, though. Why not? Because like think about, like, if you are not a like you are doing like you want to be able to hire people easily, and because like Python like is easy to learn, there is a lot of people in Python, even although those people are bad, you know, you just like you give them money, like eventually they do this, you know, because there's like just more people who know Python. There's people who know Haskell, you know. Exactly, they are bad. Well, yeah, but it's still easier to hire. No, like, what if you hire a person who knows Haskell and they're still bad? You know, it's a risky thing to try. Maybe easier to hire is bad. Okay, yeah, maybe. I never was in a position that I was the one who is hiring people, but like maybe like it's easy to get into hiring people by hiring people that are a lot of people like that, you know, like a lot of Python developers. Like it's same as Python, right? You learn programming easier with Python, and you learn how to hire easier by hiring Python developers. So maybe like that's like the same stuff. Languages like Haskell are generally self-selecting for better programmers. Yeah, maybe, I guess. Okay, let me confirm one more time that my solution here. So like, see what we're doing here. This is the most complex function, and we are doing three-dimensional dynamic programming here, basically. And this thing is up to 300. So my time complexity for this thing is just q to the power of 3 multiplied by 3, which I thought should not be that much, right? We do... Also, Python is very good for being a calculator program, by the way. I like doing Python for being the calculator. So we do 300 to the power of 3, and then we multiply that by 3. That's my complexity. And that's like absolutely very small thing. So I don't get why I'm getting the time limit here. Depends on the project. If you need fast iteration, it makes sense. I don't agree with that, actually. I don't agree with that. You have fast iteration of introducing new bugs, and the fast iteration of like trying and testing the fixing of the bugs that you introduce just because you're using a language that allows you like for easier like making bugs, you know. So it's a lot of it's faster iteration, but it's a lot more iterations because of a lot more bugs. So I'm not sure if it's worth it. And yeah, I'm pretty sure it's not worth it, actually. Is it because I'm borrowing here? Like, I can try moving to unsave, but I don't want to. There's a huge trade-off there too. Maybe you drastically change your design in a string language, you know how to redo everything and nothing compiles. And the Python duck type, yeah, but like, I don't know. In static type language, when you do a big refactor, the compiler tells you where things are going to go wrong. And in Python, you are going to, so instead of working through the compiler errors, you are going to go through testing and finding those bugs. Maybe it will seem faster because you're not going to catch all of those bugs immediately. But I'm pretty sure that because you need to run and do stuff, you are going to actually perform the refactor much slower. That's why in those languages, like, if it works, you should probably not touch that. That's true about Python. And I would probably never touch and do like almost any refactorings if I'm working on a Python code base. But in Rust, I can do it very aggressively and not worry about it most of the time. But if you're experimenting, you can often waste a lot of time trying to figure out what the fuck types should be. I don't think. I don't know. I have never been in a situation where I am where it's hard for me to figure out what the type should be. It's most of the time very obvious. If you don't understand what the type should be, you don't understand what you are building. Like, I don't know. Anyway, I need to finish this. I am so close to finishing this. Hold on. What is wrong? Why am I slow here? I don't think it's because of the ref cell. Like, it's me doing the wrong. Maybe like my time complexity is not the q to the power of 3 as I'm thinking. Maybe it's something else. Let's see. Calculating the next person. This is just, we are just iterating here. This is all q. Linear time complexity should not be any problem there. This is also linear time complexity. Calculating the cost for this from this. So this is q squared complexity, which should be no problem, absolutely. In a theorem prover that's often the crux of the work. Maybe I have never written a theorem provers, you know? Yeah. Maybe I just never did a theorem prover. What is that? What even is that? No idea. This means the dependently typed language. Okay. Next person. This is me calculating the next person. We just get the maximum out of those three. Add one. Get the from the recalculated array. Okay. This is O1. There's just 3 elevators that we have. Type system where you can have values in types. Yeah, I know. Haskell is not a dependently typed language though, right? So are you saying that it's hard because you're writing a compiler yourself? You are inventing a language yourself? It has some of extensions that make it sort of pseudo-dependently typed. Okay. Not aware of those. I mean, I'm not a Haskell user. I almost know nothing about Haskell. I know almost nothing about that. Is it because like there's no way my it's just like because of the small tiny things like over here, like because we're doing checking, like bounce checking, for example, right? There's no way. This is the thing. Because I used an optional U64 instead of like modeling my infinity with none. I could do the I don't know, like a very big number instead. That's what you usually do in competitive programming, because like that adds overhead. True dependently typed language is Idris. Yeah, I did hear about Idris. Incredibly unwieldy because you have to start doing proofs. Yeah. I did read through the Idris page a little bit. Well, I don't see any problem, which means that I should just get into optimizing it, right? Sorry for the type rent. Yeah, no problem. I feel like dependent, like I've read a little bit about dependent types, but the thing that like I want more is not that. The thing that what I want more is the algebraic effects. I don't even want the monads. I want the effect system more. I feel like it's better approach. I was looking into the Coca language not so long ago, and that's what made me want that. But I don't know if you have seen this or not. I think their implementation is kind of nice. But the language doesn't have enough features. Like that's basically the only feature that they have. I want more. I want like Rust plus algebraic effects, kind of. So like one of the thing, I can turn this option usize into something else, right? I just wish I knew how much do I need to optimize here. How do I do this? Good man, is this for Big Mo Jam? No, I'm not sure if I'm doing Big Mo Jam anymore. We are going to, but I don't know. This is not for Big Mo Jam. I'm just trying to figure out what I'm going to do next. Am I going to do big mode or am I not? I'm just doing some random problem solving. Yeah, I don't know. We were going to with like Batcom and but yeah, I don't know. Maybe I will still will. Looks like Batcop has an idea, but I don't know. I don't know. You didn't have the idea you wanted to do for it? No. We were just like talking about the ideas and I don't know. I guess none of the ideas were really good. Right now, Bad Cop has an idea, and if you are asking what is Bad Cop's idea, but I have no idea because the all that I know myself is that she has an idea. I don't know what the idea is. Maybe we need to wait for Bad Cop stream and then figure that out. We also had an artist on the team, and then while we were working out the idea for a game, the artist dropped. So like that's also like I don't know, is making me not want to do the gem that much anymore. I am more excited about like instead of doing big mode to do the Bevy gem now instead, which happens in 2 days and 6 hours. Maybe I do this one instead. And at the same time, there is also going to be the Honest Gem. And I can do a game that is going to be for both of them. Hello, Shadow Crashers. I had the programmer on our team drop out of the gem day 1. It's better that when it happens day 1 instead of day 300. How long until the big mode gem even is over? We have 15 more days, okay. Alright, anyway, I'm trying to solve this right now. The problem here that I think I've solved, and I need to make it work faster. You make Unity games, so Bevy Jam seems impossible to you? Yeah. I use my own custom engine. I didn't even use Unity ever. And Bad Cop wants me to do the big mode in Godot, which is going to be like GDScript, which is like Python, which I hate. So yeah, that's also a part why I don't really want it too much. But it could be cool to like try Godot at the same time. Godot? Yeah. That's how you pronounce it. It's not Godot, it's Godot. Okay. Godot seems alright. Yeah, it seems alright. It's just the language that I don't like. We were just talking about why we don't like Python. Okay, let me make sure it's not the input. That is wrong, right? Well, I'm pretty sure it's not the input. Also, we're not using that much memory. Maybe, like, am I going to make it work slower though if I change this from U64 into an option U64 because that's what I want. That's what I'm actually like calculating, right? And actually it's option U64. I don't know. Let's go to make it only slower. What should I do? What would be the slowest part of this? This thing, right? Let's try. I really just don't want to know what to try. This is so stupid. Maybe I have a bug with infinite loops, looping or something. Like I literally don't see what would I make faster after other than doing micro optimizations. There's no way for this problem where Q is 300 that the Q 300 Q to the power of 3 multiplied by 3, because this is like the number of elevators. Like there is no way the time complexity like that needs to be like micro optimized, right? When we have 5 seconds on the time limit. I did something wrong. I did something wrong. We can try generating something, right? We can try generating a thing. Let's try generating a thing. We don't really need to generate a test case, right? We just need to do 1,300,000,000, and then we do 1, 2, 3, 4, 5. This is 10, 20, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 300. Okay, and then we need to do 300 lines of something like person is moving from floor 1 to floor 1 billion. right? And then we need to do 300 lines like that. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. This is 30 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the biggest test case that we can do, right? So I need to run this with optimizations on though, right? Release. So this is working very long time actually, right? This means that I actually did do something wrong. Wait, hold on, but how much time is it? It's not that much time. I feel like I need to optimize it like twice. All right, maybe we just use unsafe for like remove the bound check-in or something. It worked for 13 seconds for me. Okay. Okay, let's see. Let's see. Unchecked. Get unchecked. Get unchecked. Get unchecked. Next. Right? Something like this. And then we do unsafe. And then we do... And then we do unsafe. Okay. Whatever. How much is this going to do for me? I don't expect this to be much. Maybe apps diff is bad. Maybe this thing is slow. The absolute difference of two unsigned. This actually made it slower. Hold on. I added bound check. I removed bound checks and it made slower. It made the program slower. Actually, this is just like the RNG part of the timing. Okay. Maybe we do instead of the ref cell. Instead of the ref cell, we are going to do unsafe cell. Right? So instead of borrow, can I just do get? And then we just use that pointer instead, right? Ref cell expected unsafe cell. Is there a constructor? Yes. Is this going to make it faster? It's not, right? Like there's no way. It should not matter that much. Yeah, it does not matter, like literally. Hold on, what is wrong then? Let me undo those changes. I don't want unsafe. That is ugly. Like unsafe does not help. Get unchecked. This did not help. Okay. What should help? Let's remove this math and let's just do it a little easier. We do self f, just this stuff. Like if I remove the math here, is it going to run fast? I mean, it's going to optimize this stuff away maybe now. So this did remove a lot of time. So does this mean that... Oh wait, hold on, min cost day, hold on. Is it because of that? Maybe because I'm using a hash map there actually? There's no way. This makes it a lot slower indeed. Okay. Hold on, but this is even less complexity than we had. Why would this be slow? Okay. Let's remove that. Let's try making this one fast to make sure that this is the problem. I'm just going to return. I'm just going to return some 0 from this, right? Because then we're not going to do anything here. Is this the reason we are slow? It looks like it is. It's still 5 seconds on my PC. I'm not sure how much slower or faster are the invokers there. So what is slow here? Because, hold on, you are saying that it takes me 5 seconds to calculate this stuff, which is the time complexity to calculate all of that, because I'm doing memorization here. Oh wait, hold on. So maybe it's because I'm calling this function and I'm doing the hash. It's because of the hashing, I guess. I'm doing hashing a lot, right? So I need to just use that thing, right? Okay, let's just redo how we do it. So like minimum costs is going to be, let's just do instead. So for all of the 3 of our elevators, we're just going to be like, let's do backpack of optional U64, right? So we're just going to calculate that separately. Like that, I guess. Okay. So we do from is going to be from 0 to Q. And then 2 is going to be from 0 to Q. Right? And over here, we are doing that. I guess we need usable here. Oh wait, I need to like use it though. Hold on. This is bad. Just do back of 0q q something like that. And then we do for from in 0 to q, for q in from to q, right? And then over here we're actually like calculating. It's none here. So we say that costs from to 2 is going to be equal to this costs from +1 to 2, which means that we need to do that in reverse order. A is moved. I'm going to move it later. So from needs to be in reverse order so that we can refer to the next one. It should be like calculated already. Okay. Let's see now. Okay, I literally just improved the time twice. So like the most of the time was spent in the hasher, I guess, because I used hashmap here. And when calling this function in a hot loop, I was like getting. Okay, so this is now 5.6 seconds on my PC, and the time limit here is 5 seconds. Let's see if this is going to work. I wish they just did the time limit more, or like constraints smaller, I guess. I don't know. If I have written this using like the competitive programming style in C++, then it would just pass immediately, I guess. Because I don't do like option. I do like -1 instead. Right? Like, this is just going to pass, right? Yeah, accepted, okay. So like, I don't know. I feel like the original style is like, I liked the style of that code more. But anyway, we did solve that. I did not solve one of the other problems that has been solved by a lot of people. This one, the age. I did not solve it for some reason. Maybe it's because I didn't think about it too much. But instead I solved this one, which was solved by only 38. Okay. I don't think I'm going to do all of them. I just did it to see how well I will do in 5 hours, and then we upsolve the problem that we almost solved during the contest, I guess. And I think that's probably going to be it for right now. Although I think I'm later, in about maybe half an hour or something like that, I'm going to do another competitive thing, which is going to be competitive gaming instead of competitive programming. It's going to happen on my other channel. In case you guys are interested, I'm going to play a 40 game, and I'm going to do a speed run of it. The other channel is called Kuvi Boy. That's where I play games instead of making games and doing programming. In case you're interested, you can follow there. I'm going to play this game called Hans, where you play as a watermelon, and you need to go up and not fall down, basically. But that's going to be it for me for today.
Oh, but then we have to box these ones.
Here is Togglebit doing some Rust for you guys. See you next time. Bye. Maybe next time we are actually going to work on a game. Probably. We'll see what that is going to be.
Right.
Godot
So
or not.
boxes as well, yeah. And this one boxes, yeah. And then this one is our manual box, so that's fine. Okay, there we go. We got